Welcome back, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers, and we're here for day 5 of our AWS Certified Solution Architect Associate 2022 free full AWS course bootcamp. I hope you all had a great time this week, and we're here for the last day for the finale. But before we get into the things that we're going to be talking about, if you can let me know that you're here by giving me a hashtag AWS Certified Solution Architect Associate. I want to see who's here and where you're at. And in case you missed the previous days, don't worry, you can go back and watch our AWS Solution Architect Certification Bootcamp. All 4 days, they're going to be stored on our YouTube channel. Now, we want to make sure you get full, great training. So in this free AWS certification training course, we're here to do anything we can to help you build your absolute best career. I've been working in this industry now for 25 years. Been helping others get their first tech job or get promoted in tech for more than 2 decades. And I want to make sure you get cloud hired, cloud promoted, and have your best cloud computing career. This is an AWS Cloud Computing Flood course, at least as it pertains to certification, which is a bit different than what it takes to actually getting your first solution architect job or cloud architect job. But we want to make sure you've got this, you pass the certification, and I'm going to give you some guidance along the way to do it. So before we begin, there's a couple of really incredible things we do for free to help you build your best cloud computing career. The first thing I want to let you know is next Thursday, we have our completely free webinar on how to get your first cloud architect job. What we do here is we'll teach you how to leverage your past experience, how to show the hiring manager that you're exactly what they need by telling you exactly what the hiring manager is looking for. We'll cover the exact skills you need, the things that need to be on your resume, and how we train you or how you can train yourself. It's completely free. Sign up for the completely free webinar. Now, the next thing I wanted to let you know is that we've got a book that goes along with it. There's been over 100 people that work together on putting out this book, and we're going to announce their names this week. Hundreds of years of combined experience to help you pass the AWS Certified Solution Architect Associate and Professional exam. The book is completely free. Please download it. The link is in the description below and the chat box. And of course, I want you to get some hands-on time. Now, I saw the 99% of courses that are out there, which is why I came out of retirement, because the certification courses I saw were terrible. And I came out of retirement to help you all get cloud hired. And what I saw is everybody can easily get certified, but they don't know what the tech is. So we're going to focus on what is the tech, how does it work, and why you should use it or not use it for that matter. But I still want you to get hands-on. So please sign up for the free labs, which you can do all on your own time. My team work together to build them for you. So sign up for the free lab descriptions. The link is in the chat box and the description below. And finally, if you're looking to get hired or you're looking to get your first solution architect job or cloud architect job, we've got a 30% off discount code using coupon code SECURITY, and we're happy to do it. That's the maximum discount we will ever do, or generally will ever do. And it's here for you right now until Sunday. So get it before it expires tomorrow. That's your last chance for a long time, potentially, to get 30% off on our products. I want to know you're here again, so give me a hashtag of where you're from. Give me a hashtag cloud architect, cloud engineer, solution architect, based upon the career you want. And when I see that, and I see them coming in, and I know you're awake, alert, and oriented, then I will be there. And we'll start the training. Come on, I know you're there. Okay, I'm seeing it from Dream Planet. I get a couple more, and then we'll begin. All right, I'm starting to see them come in. I know you're awake, alert, and oriented. Now I'm feeling good. Good to see you, Elvis, Cash. Fire and Dream Planet. I'm loving all these cloud architects popping up there. More cloud architects in Virginia now. I'm starting to feel happy. Cloud architects in Mexico. I know it's Maria Mauricio. MBWA Lambert, Cloud Security Architect. I like that. Collins, Cloud Architect, Boston. Cash, AWS Solutions Architect, Boston. Eric, good to see you in Boston. In the Netherlands, fantastic. And Jennifer, Cloud hired. Okay, so we're going to begin. Effie, also good to see you. So the first thing we're going to talk about today is the certificate manager. When you're dealing with websites and HTTP and HTTPS, what you're really dealing with is you want to make sure that it's encrypted. And you have to identify that the website is who they claim to be. For example, if I was going to a website to go buy cat toys, right? If I thought I was going to a cat toy website and instead it was a hacker's website, that hacker could steal my credit card information and my beautiful cat Cindy wouldn't get the cat toys. So two things would happen. My credit card would be compromised and my cat Cindy would be really sad, and we don't like my cat Cindy to be sad. So we need to know that we're connecting to a website that they are who they claim to be. And there's not a hacker in the middle. So that's what we do, is we put a certificate on a website. The certificates on our website enable us to determine who they are, help us do our encryption, verification, and things like that. And the AWS Certificate Manager is a service to help you do that. And Certificate Manager adds protection to websites by using certificates to establish safe and secure connections. Now, Certificate Manager itself is an AWS proprietary service that enables for the simple provisioning, management, and deployment of your certificates, both public certificates and private certificates. What's the difference? A public certificate you put on your external website. A private certificate you might do on your internet, which is accessible only from your internal network, not the internet. And Certificate Manager allows users to deploy certificates on AWS resources very quickly and efficiently. And Certificate Manager provides free and public certificates to services like our load balancers or our API gateways. Now let's look, graphically speaking, for about a moment what Certificate Manager actually looks like. You can see in this environment, we've got a Certificate Manager that we can put on our Elastic load balancers or our CloudFront content delivery network. Mind you, in reality, many organizations will use many content delivery networks, at least one or two, but we can definitely put it on the CloudFront distribution. So Certificate Manager is going to help you with security by making sure you can identify and use basic encryption, HTTPS type encryption, or SSL-based encryption, otherwise known as TLS encryption, for your website. Let's talk a little bit more about Certificate Manager. There are two options when deploying certificates, and there's going to be the public and the private CA. And private CA is used for communication inside of your organization. Now, private CA certificates you have to pay for. And these are basically what happens. You can issue a certificate, put on specific users, computers, applications, or servers, and that way internally your users can authenticate a system and the users can be authenticated. Now, with a private certificate, you can't use it on the internet, right? Because it's private. Now, public certificates obviously are public and they're free, and you can use them for your external facing websites. Now let's talk about Kendra. Kendra is another service, and it's a fully managed service managed by machine learning. Now, Kendra lets users search through structured and unstructured data. And what happens is Kendra uses natural language processing to understand the context of a user's query and find relevant answers. What'll happen is Kendra will index your documents, whether it's unstructured text such as HTML, PowerPoint file presentations, Microsoft Word documents, plain text documents, or PDFs. Kendra is capable of indexing structured text, for example, a frequently asked questions. Now, document attributes can be used to with Kendra can be used to filter responses as well as queries. And of course, we can set up custom attributes that can be added to documents as well as very specific searches. Now, with Kendra, our queries can be directed towards more relevant results by increasing or decreasing the importance of an individual field in the index. How tight do you want to search is really what we're talking about. And if the user adds more weights than the importance of the highest replies or views, users can see postings that are more popular or hot on forums. So it gives us the ability to use machine learning to parse through a fair amount of information. And the type of machine learning we're using in this particular case is natural language processing. Now we're going to get into Kinesis. And Kinesis is a streaming service. Now it is a proprietary streaming service. So many organizations can't use it. Again, Kinesis to me feels like something that you could toss away and replace it with Apache Kafka. And many big organizations in the cloud have done so because they don't want to lock themselves into a proprietary solution. But this isn't reality. This is an AWS Certified Solution Architect Associate and/or professional help training. And when you're dealing with an AWS certification, it's designed to make sure you know the AWS product set, kind of make you excited to go recommend it and sell it. So we're going to talk about it. Again, this is in a multi-cloud environment or a real critical high availability situation. You're going to be using Apache Kafka, not Kinesis. Now, Kinesis is a service for collecting, processing, and analyzing streaming data. Now, Kinesis can collect information in real time, and that's kind of nice, but you can do this with Kafka as well. And typically we use it for video or application logs or website click streams or IoT devices. And normally there's two ways of collecting information. You could just collect information in system logs and store it, and then analyze it later. Or you can use a streaming service like Kinesis or Apache Kafka, and you can connect the data in real time, and you can kind of analyze the data in real time, visualize the data in real time, and think about it this way. What kind of a competitive advantage could you absolutely get? If you have historical information, you can make data after the fact. But if you have real-time information, you can make much better decisions. Let's talk about Kinesis. Kinesis is ideal for situations when large amounts of streaming data need to be processed and rapidly moved. Think of it this way. If you had weather sensors all over the Caribbean and Florida, and a hurricane is coming, how cool would it be to have access to be able to look at that information, visualize that information, and analyze it in real time? That's what we're talking about. Or a bunch of airplanes flying around where you want to get their status and make sure they don't bump into each other. It's high traffic when you're actually in these airplanes. We don't realize it in our seats, but the pilots will tell you it's like a congested highway over there. So kind of keep that in the back of your mind. Now, when we talk about Kinesis, we're going to talk about 4 platforms, and they're going to be Kinesis Video Streams, Kinesis Data Streams, Kinesis Data Firehose, and Kinesis Data Analytics. Let's talk first about Kinesis Data Firehose. It's a managed service to load streaming data into data stores, data lakes, and analytic services. Kinesis Data Firehose can capture streaming data and put it into S3 or Redshift, as well as many other services. And it's fully managed and auto-scaling, and it'll scale as you need to for the throughput with auto-scaling. And of course, you can monitor what's going through Kinesis Firehose. Now, when data is going through Kinesis Data Firehose, or Kinesis for that matter, the throughput is going to be measured in shards. And a shard is basically going to be 1 megabit per second. Now, that doesn't sound like a lot when you're dealing with video, because it's not. But when you're dealing with little text files from internet sensors, those kind of things, that's a lot of data. Now, when you're going to do, you obviously could use multiple shards. And the pricing is going to be based upon the number of shards. So like anything else, prior to use, your organization should determine the required shards in terms of capacity. And of course, you can increase it when capacity is needed. A little more about Data Firehose. We can use up to 10 shards per region per account. And if we need more than 10 shards, no big deal. We just contact AWS support and they can enable it to work. We could also set up an auto-scaling policy to auto-scale the number of shards based upon utilization. Now we can set up Kinesis Data Firehose from the console. Setup is essentially setting up the sources and the destinations for your data. Now we're dealing with Kinesis Data Firehose. Streaming data is captured by the Firehose, and we can send it and store it in S3, and we can also analyze the data tools with analytics tools. So let's look at what this typically could look like visually. In this environment, you can see we've got multiple data streams coming in. We've taken these data streams in, and we've popped these data streams into Kinesis Firehose. From the Kinesis Firehose, you can see that we're putting it into an S3 bucket. And from there, what we're actually doing is we're using analytical tools to kind of look at it. Maybe something like Tableau or Tableau or Power BI. Those kind of analytics tools give us the ability to parse through large amounts of information and actually visit them. Now let's talk about some Kinesis Data Firehose concepts. With Kinesis Data Firehose, we basically have a delivery stream, which is data coming in, and you set your Kinesis Firehose by creating a Kinesis Data Firehose delivery system, and then we get a record. And the record is the data that's ingested. Record can be as large as 1 megabyte. A few more things as we talk about Kinesis Data Firehose. We've got our data producers, right? That's the stuff that's sending you the information. Our IoT devices, for example. We also may have a buffer size and a buffer interval. And what is that? Well, when we're dealing with Kinesis data coming in, it buffers internal incoming data streams to a certain size for a certain period of time before delivering it to the destination. Makes sense. Bundle up your data, send it, bundle up your data, bundle up your data. And it's not a lot of time that it's going to be there, but it's a short buffer interval. Now, we talked about Kinesis data firehose. Let's talk about Kinesis video streams. Every connected device, such as a smart car, smartphone, camera of any kind, we can use that data with Kinesis video streams. So we can pull information from all kinds of video devices. We can store the information, convert the information, and encrypt it, or we can analyze it in real time. And Kinesis video streams automatically scales to handle any amount of data, and it's used by analysts, AI, machine learning, and that way we can look at what's coming in and analyze it in real time using tools. A Kinesis application specifically for video streams. So video streams enable the ingestion. So it's really about pulling things in, as are all of these things. And one advantage of streaming through this platform is that users can collect, save, and process and analyze data. So let's look a little bit about Kinesis video streams. Here you go in this environment. We can be taking in data from a lot of different places, analyze it, and use it for media processing. Let's look if we wanted to crowdsource a video thing, for example, and we wanted to basically enable 1,000 users to be streaming their video so we could create a movie based upon cell phone information. Imagine using Kinesis video streams, pull information from a variety of sources, and wow, you can do something very cool. So Kinesis video streams is a nice concept. Now, we've talked about Kinesis Firehose. We've talked about Kinesis video streams. Let's talk about Kinesis data streams. Now, Kinesis data streams is a scalable platform to capture real-time streaming data. And it can capture data in real time, and you can actually analyze it within 70 milliseconds, which is pretty darn fast. Imagine capturing capturing gigabytes from hundreds of sources, or hundreds of thousands of sources, and instantly making a decision. Financial transactions, location tracking. So Kinesis streams can ingest data and then export it to a business intelligence tool. What's happening is the streaming data is going to be captured by Kinesis data streams. It's then sent for processing, and it can be sent to a tool like Power BI. So let's look at what this actually can be used in concept, and then we'll talk about some Kinesis data streams term. Here we go. We've got our data coming into Kinesis data streams. Now that our data is coming into Kinesis data streams, it's sent to Kinesis. Now we could be using, say, Power BI or QuickSight or some tool like that. And we can look at our data and do something about it in real time. Now, when we talk about Kinesis data streams, there's a couple things which could pop up on your exam. So let's make sure we talk about it. We've got the data producer, which is the application that emits the data records. And what will happen is the data producer will assign a partition key, and the partition keys will ultimately determine which shard is going to ingest your data. And of course, we're going to have the data consumer. What is the data consumer? It's what's receiving the data from all shards as they're generated. Most data consumers are receiving the most recent data in a shard, and that's going to be used for real-time analytics or handling of your data. So let's talk about when we would use Kinesis data streams: large event data collection, real-time data analytics, capturing gaming data, for example, or capturing mobile data. Quite useful in a lot of cases. Now, let's talk about Kinesis data analytics, a new service, or a different service. Now, Kinesis data analytics is going to be a managed service that's used to transform and analyze streaming data in real time. Kinesis data analytics uses the built-in Apache Flink to process data, which is what many organizations use for big data processing. Kinesis streams is auto-scaling, which means it's going to scale the needs to meet your organizational needs. And data on Kinesis data streams can be queried via standard SQL type queries. Sorry, I'm trying to call it data analytics. I'm calling it data streams. Apologies for that. So let's look graphically at Kinesis data analytics. You can see we have a data stream that's going into analytics, and then it's going to a business intelligence tool. so we can analyze the information and have better business decisions in real time. Now, AWS knows most people would not use this. They use Apache Kafka by building their own Apache Kafka servers. So now they're trying to make a managed streaming platform for Apache Kafka. And now that's exactly what managed streaming for Apache Kafka is. It's a fully managed service that allows users to build and run their own applications and use Apache Kafka for data stream processing in AWS. Of course, you could build your own and not use any of these managed services and use those same virtual machines in multiple clouds for high availability. But if you want a managed service and you don't want to manage the server or the operating system and patching it, here's your option. So managed streaming for Kafka is a fast, scalable, durable, and fault-tolerant streaming platform. And it's going to provide a unified, high-throughput, highly distributed messaging system. And it's a low-latency platform for handling real-time data feeds. It's distributed, partitioned, and really basically gives you a good logging environment. It provides a publish-subscribe message bus that can be used to build real-time data pipelines and streaming applications. Managed streaming for Kafka is a distributed platform designed to handle large amounts of data. It can be used to store and process large amounts of data. Let's talk about another service which could pop up on your Certified Solution Architect Associate or Certified Solution Architect Professional exam. AWS Outpost. And what is the AWS Outpost? It's basically, AWS would define it as a fully managed service that uses EC2 instances or a series of EC2 instances configured inside of your VPC in an appliance. What is it really? You go buy a server from AWS, you store that server inside of your data center, and AWS manages that server, and now you've got EC2 instances inside your data center. Now, the reality is you just put your own server here and manage your own systems, and you don't have to buy that server from AWS, but you have to manage it. So that's what it is. It's a fully managed server that's got your own virtual machines that you stick in your data center, and they manage it for you. The AWS Outpost appliance acts as a virtual part of your VPC. Yeah, part of your VPC, even though it's sitting in your data center, which is placed in your data center. Now, why would you put this AWS Outpost in your data center? Because the latency to the cloud is long and slow, and even edge computing is not that great. So by putting the server in your data center, now you've got a beautiful environment. Of course, you don't need to buy Outpost at all. You could just get a server from Dell, for example, and it'd probably be a lot cheaper. Of course, you'd have to manage it yourself. But if you don't want to manage the server yourself, you can get the server from AWS. And because that way it's part of your own EC2 in your VPC, you could use the cloud tools to manage it as opposed to the standard tools to manage a server, whichever is easiest for you. So now let's talk about Comprehend, another machine learning service from AWS. And Amazon Comprehend is a natural language processing service. And what happens is natural language processing is a machine learning artificial intelligence service that gives computers the ability to interpret text or speech, similar to the way the humans do, but not exactly. What happens is human language will be dissected into pieces so that the grammatical structure of the sentences and the meaning of the words can be evaluated by machine learning. From there, natural language processing will extract critical elements from the data. Natural language processing can identify patterns as well as recognize the sentiments of the context, which is pretty cool. But we've got a long way to go. With the intelligence to mimic human abilities or understanding language context, natural language processing can help save businesses money because it can automate processes. For example, recognizing client behavior and the preferences of voicemails and text, mining data from various sources, making it easier to extract useful information so that businesses can have a better understanding of the insights of the customers they're serving, for example, dissect the meaning of videos to see if there's any negative content that needs to be flagged, categories of documents. So a great way to use technology to look through your video context and all your things and text context to see if anything's offensive, not good, get a sentiment of your customers. It's great. These are great tools. Now, AI tools are not a replacement for humans. They are supporting humans because the humans have the ultimate judgment. No machine learning tool has ultimate judgment, but it can parse through large amounts of information and help provide decision support so the humans can actually make better business decisions. let's talk about Elastic Transcoder. Now, this is a service for converting videos between various video formats in the cloud. It's easy to use, cost-effective, and highly scalable way to convert videos that somebody stores in S3 to some other verb. Now, you can do this on your own servers. It can be done in the CPU and the GPU, but it's computationally expensive. So what is this really about? I could actually shoot uncompressed video and have a 1 terabyte file after 15 minutes of video. Now, I can't stream a terabyte inside of 15 minutes because most users don't have the internet bandwidth for that because they don't have a 10 gig internet link. So what happens is we take our video, we put the video into a compression algorithm, typically called the codec. And the codec, which is not exactly a compression algorithm, but it's mostly a compression algorithm, will change that video format to, say, an MP4. And by doing it, it can take video that might be a terabyte and make it maybe 10 gigabytes or 20 gigabytes. So it's packageable and streamable and distributed. And Elastic Transcoder can do it for you on the cloud, so you don't need big Xeon systems or big AMD EPYC servers to do it. And these things, like I said, they're very computationally expensive. I can tell you internally, when I need to transcode a video, I use a system that's got 64 cores and a $2,000 GPU in it and a half a terabyte of RAM. So you could buy a system like that, where you could pay to use a service like Elastic Transcoder. What's going to be the determining factor whether it's good for you or not? How many of these things you need to do, and how often you need to run these systems. So Elastic Transcoder is easy to use because it's got a very clear workflow and predefined video formats that can be selected for lots of output devices. It's available in various AWS regions, and users can just transcode their content wherever it's stored. And users are paying only for the minutes needed to transcode the videos. Let's talk about Poly. Now, Poly is a cloud service that's going to transform text into lifelike speech. Dozens of voices are available in different countries, and it gives the user the ability to create a web page with somewhat realistic speech. We've all been to websites where it's got like some robot that's trying to read you an article, and it sounds sort of human. That's what we're talking about here. Poly's text-to-speech technology uses artificial intelligence to create natural-sounding human sounds. Now, neural text-to-speech is a service that can improve the quality and get better with advanced speaking styles. It can be used to help people read through a document at a faster pace, or even narrate a book while on the go. This can vastly improve productivity. Many people can read much faster than they can listen. Other people can listen faster than they read. So this is your mileage may vary. Now, Poly can return audio as a real-time stream. And this is going to make it ideal for a call center, because that way we can use reactions for prompts during phone calls. Poly can be used as an announcer or public transportation system, perfect for that kind of application. Giving it up-to-date schedule information that would be beneficial to the user or someone visually impaired. From games to interactive media, it can be used to basically react to tailored speech responses. Chris, did we reach 20 minutes where I should open some questions?
Continue going. You've got about 2 or 3 more language things to do, and
Okay.
then it changes.
Okay, let me do a few more language things. Let's talk about Rekognition. Rekognition is a way to analyze videos and images using machine learning. Now, this is kind of a cool tool. Amazon Rekognition is used for identification of individuals in a video, analysis of emotional state based upon facial expressions, identification of unwanted content in videos, the ability to search a video for a different person, labeling of images, detecting anomalies. Now, this is pretty cool because in real life, there's lots of times where you get a lot of information. Think of it from a security perspective. You're in England, they've got London has cameras everywhere, and there's a threat. They can use something like Rekognition to kind of go through this. Or think about your business. You want to make sure there's nothing in your business from your users that could be brand damaging. So Rekognition is quite helpful. Let's talk about Textract. Amazon Textract is another machine learning service that can extract text, handwriting, and data from scanned documents, JPEG, PNG, PDF, TIFF. It's kind of like the old school optical character recognition with machine learning to make it smarter. Amazon Textract works by reading and processing millions of documents using machine learning, which is a combination of various application programming interfaces plus learning all the stuff that's there. After reading context, Textract can extract text, handwriting, and information. Textract can automate document workflows using AWS Lambda functions by making API calls. Now, using Textract makes it easier for companies or businesses that deal with a lot of documents to automate the processing and extracting of critical data in an easy and cost-efficient manner. Textract is useful when it comes to the ability to extract critical business data, such as applicant names, mortgage rates, and invoice tools, I should say. Let's talk about Translate. This is a service that can provide translation of 25 languages from one form to another. It's an automated language translator. Some things don't naturally translate for real, and we humans actually have to basically come up with things. Like if I were to say to Chris, open the lights, he'd look at me like I have 4 heads. But if I said to him, turn on the lights, he'll know what that means. Remember, some things don't naturally translate, and that's going to be your weaknesses with these kinds of things. Keep that in the back of your mind. So it's a service that'll provide translation. It uses artificial intelligence, machine learning to try and translate as accurately as possible as time and demand permits. People of different languages can communicate despite their language barriers. Translate uses neural networks that identify and intelligent translate languages it supports. This helps in converting one language audience to another language audience. Basically what happens is you've got an encoder, and the encoder is going to read through the text word by word and then theoretically intelligently translate that and process that data so what the text is supposed to mean. It's aided by a neural network node called attention mechanism best understand the text. And then it's got a decoder, and the decoder is going to use the semantic meaning to translate the word in the text for the intended output. Now, Translate is a service that can be used to detect an input source language and tell the user, realistically speaking, what language they are using to aid that, to enable a multilingual user experience in your application. Translate company-authored documents such as meeting minutes, technician reports, knowledge-based articles, and posts. So let's open it up for some questions. Actually, I'm going to talk about Alexa, and then we're going to go to the question and answer session. What is Alexa for Business? Alexa for Business is going to improve the usability of conference rooms and offices by providing a more streamlined method of accessing your company's schedule, tasks, and information. By utilizing Alexa for Business, companies can develop Alexa skills curated to their staff or clientele. Alexa for Business enables IT to centrally manage and deploy Alexa devices for use by employees in shared spaces, etc. You can put it in a conference room, a huddle space, a phone booth, a lobby. Any physical person in possession of a shared device can use it. Okay, let's take some questions here now, Chris.
All right, now we're getting to the fun questions.
Shameless, as a cloud architecture, do you have to know this in depth? No, as a cloud architect, you need to know how to design this stuff and what stuff you could use. Now, the reality is at least 50 to 75% of the stuff I've mentioned so far, you wouldn't use in a real architecture anyway, because many of these things are proprietary. You talked about all that Kinesis stuff being proprietary, how you'd replace it with Kafka. We talked about why you shouldn't use DynamoDB, for example, when you have a multi-cloud environment. So some of this stuff you need to know, and some of it you don't. Now, it's funny, people get hired every day with no experience out of our training program. And why do employers want experience anyway? They want to know that you know what's important and what you don't know. And they want to know that you can't use 80% of the stuff. They want to know which parts are valid and which parts are designed to help you just think that you can only use a vendor stuff. Now, for the exam, you have to know all of this. In real life as a cloud architect, it's much more important for you to understand business, the customer's business goals, the business pain points, the business challenges. It's also critical for you to know the underlying technology they have and what it is, how it works, and why they use it. It's also critical for you to know how to improve their business and what kind of technology that means. Is it AWS cloud stuff or is it not? For example, yesterday and even today, guess what? AWS is not using CloudFront for their own company. They're using Akamai's content delivery network. But they're teaching about CloudFront, but they're not using CloudFront yesterday and today. Yesterday, when we did an NS lookup, the Amazon website was on the Akamai content delivery network, not the CloudFront content delivery network. As it was today, they're also on the Akamai content delivery network. Now, they may use two content delivery networks, not one, but you've got even the cloud provider themselves that are using external vendors for that reason. So you can't use just this stuff here. And Camille, all the stuff you need to know in a cloud architect is not covered in certification. The ability to know what customers need, the ability to understand the business, the ability to know what business applications are going to solve customer business problems, how to optimize the network for availability, how to secure the systems, none of that's really covered in certification. We're discussing the proprietary services in these certifications, which is very, very, very different. So for exam, you must learn this. Now to work as a cloud architect, you need to learn how to be a cloud architect, and that's not covered in any certification. I really wish it was, but it's not. As a cloud architect, you need to understand how to design, present, and sell a solution, and unfortunately, none of that's covered in any of these certifications. And that's why we have our Cloud Architect Career Development Program. But to pass this, you should know it in depth. If you're asked some of these things on an interview, it would be good to know them. Now, the reality is on an interview, you're going to be asked more about object storage or block storage than you will be S3 or EBS. You're going to be asked more about load balancer concepts than an ELB. You're going to be asked, how do you design something? And they expect you to know that it's not just AWS stuff. They're going to expect you for security to know about next generation firewalls and IPS systems, all this stuff was here. So Camille, what I'd say is this stuff is about 6 to 10% of what you would need to know as a cloud architect. And you don't need to know all this stuff because a lot of this is proprietary, but you need to know that other 95% of the stuff. And you should remember at least 70% of this stuff for your real life career that we're talking about in the certification. But as architects, we don't implement this stuff. That's somebody else's job, and somebody else can get deep in the weeds on the features and functionalities of this. We need the overall design and how do we design it to go solve the business problem. Great question, by the way. What would be some use cases when having these types of AI services internally or marketplace vendors? Why would you really use any of these kind of things? Well, you got large amounts of information, right? Now, how do you process the information? Well, you can hire a bunch of PhD statisticians. I've done it. I've seen it. I've worked for banks, and they had 100 PhD mathematicians that were calculating stuff. But that gets tiring, and it gets expensive. So we use automation and machine learning for the following reason. When inflation goes up and people get more expensive, we try to replace people with machines. So we use machine learning for that. In a contact center, we can use some of this text-to-speech stuff, and we can use it to play something so we no longer have to pay someone to read you the script. We can transfer you to the machine, and the machine can read it, and then you can go respond, and it saves your people time and effort from that. So we can use it to replace people. We can use it to take large amounts of data and parse through it, assisting the use of people doing it. But we can also use it for better inferences or better recommendations. So if we can parse through, Daniel, all kinds of information, potentially we can predict where error defects are going to occur in a manufacturing process so we can go fix it. And we may be able to capture that faster than we could. If we're dealing with virology, for example, and we've got a new virus that's out there, and we've got large amounts of data coming from 100,000 different sources, we can use the machine learning to parse through the information, and it can alert the scientists to potentially look for certain things. Now, no scientist is going to say, hey, this machine learning is right, but it's going to point them in the right direction so they know where to look. And if they know where to look, they can do this. Now, we can use machine learning in the context of security, too. We can parse through 1,000,001 security logs as part of our event correlation. And that can show us that something's wrong. And it can give us guidance. And then again, we're going to use our people, the real people that are humans, that have the ability to think, not just parse through data, to determine if the machine learning is right or if it's just wrong. So these are options to do these things. Now, there's lots of ways you can do it. And Daniel, it has to depend on your use case. In some cases, it may be cheaper to go buy a $100,000 server from NVIDIA that's got like 8 Quadro 8000 type cards in there, when you might have to pay $100,000 a month to actually be able to do it on the cloud. But the reality is the data center, is that running that thing 24 hours a day? Or can it be done on the cloud at 10 minutes at a time? Because the cloud's got so much power. So the company, like always, everything with the cloud or non-cloud has to evaluate, when does it make sense to use the cloud? And a lot of that's going to be based upon your use type. Look, if you've got an application running at 100%, 24 hours a day, 7 days a week, chances are it's much cheaper to run it in your data center. But if you've got a sporadic application, for example, then they're there. Now, who would I go to for machine learning? Well, NVIDIA, for one thing. They make the best GPUs for machine learning. AMD makes exceptionally good GPUs, but most of the machine learning libraries are optimized for that. Now, if I wanted to go to a cloud that was going to do machine learning, where would I go personally? I'd go to Google. Why? To the #1 and #2 algorithm maker in the world. So you might want to go there. But there's always going to be lots of companies that have lots of proprietary services that organizations can use. Daniel, it's never going to be limited to just the stuff that one cloud provider offers. Never in any reality. Hope I answered your question there. That's a good question. Of course, we can go to the next one if there's another one.
Are you looking at StreamYard at the
private chat? I still see Daniel Mitra's thing here.
Are you looking at my chat?
No. Can't see it. When you talk about certain servers and people would have to manage it themselves, what entails managing the server yourself? Does a solution architect manage the server? Look, solution architects never touch the technology. We design it, present it, and sell it. As a solution architect, you will go to meetings, you will go to golf, you will buy dinners, you'll buy drinks, you will build teams, you'll build a business case, you'll be writing documents, but we never touch the technology. Not in the cloud or off the cloud. That's the job of the cloud engineer. So managing the servers on the cloud and managing the servers off the cloud is the same thing. Now, on the cloud, they're virtual servers you use, virtual machines. So somebody's still got to patch them and make sure the operating systems are up to date. And that's typically done by your maintenance people, which is your sysops people, or it could be done by your cloud engineers, but usually it's done by the maintenance team. Now, who does it in the data center? Again, it's the maintenance people, the sysadmin people, otherwise known as sysops. They manage this stuff like this. What entails manage now, if it's a physical server in the data center, well, realistically, you have to make sure your hypervisors are updated. And they do that automatically. They can patch themselves. And you have to make sure your virtual machines are updated. So Quayne, it's the identical thing if you're in the data center or the cloud. Chris, no. Is it our job to do the streaming part when Kafka? No, we're architects. We design, present, and sell. We don't touch the technology. This is done by a big data engineer or a data scientist, not by the architect. Lady Godiva, I've read companies regressing to bare metal servers versus the cloud due to the expense, due to the thoughts. Lady Godiva, the cloud is not necessarily cheaper. Everybody went to the cloud thinking it was a great idea. We advised everybody to use a hybrid cloud and a hybrid multi-cloud. Lady Godiva, we have a cloud that has 10 servers with 24 cores each, 128 gigs RAM. When we went to the cloud for pricing, they wanted $11,000 per month. We bought the used 10 bare metal servers for a little over $10,000 at the time. And we're running our own cloud for $10,000 once, as opposed to $11,000 every month on the cloud. Now, sometimes it's cheaper on the cloud. Sometimes it's much more expensive on the cloud, Lady Godiva. So what happens is we have to focus on what's best for the customer. And that's why what's taught in certification versus what's taught in reality doesn't make sense. We have to look at the analysis. Now, Lady Godiva, here's where the cloud becomes cheaper. In my data center, I build a website, right? Let's say I'm a global retailer. Which day am I building for? I'm building for Black Friday in the US, the day right after Christmas when companies go from red into the black, which means profitability, busiest shopping day in the world. Now, in a normal environment, Lady Godiva, our servers, our web servers are operating at like 3% all year long, doing nothing. And we build them so big that they can handle the Black Friday and Christmas holiday thing. Poof, done. And then they're back to idle for the rest of the year. Now this, web apps and autoscaling go to the cloud because now in the cloud, we can purchase exactly what we need for that 3% of the time as opposed to overpaying. And then scale out and have more capacity for Christmas to go back down. There the cloud gets a lot cheaper. But just outsourcing things to the cloud does not necessarily mean it's cheaper. You may have to pay 10 times more for the servers. But if you're only using them a percentage of the time, paying for what you need in the cloud could be beautiful. But if you need to use it full time, all the time, the data center may be cheaper. The data center is also higher performance. The data center is higher security. So what you had is people like me and real architects that were advising our customers, migrate this stuff to the cloud. Keep this stuff in your data center. By the way, IBM or Nutanix can build you a beautiful, beautiful private cloud. You can get all the cloud benefits, and then you can capacity burst to the cloud. Now, this thing you can do in the cloud because this is transformational in the cloud. This thing you can do better in your data center. Now, that's what people like me were doing. And we've always done that. That's a real architect. For a short period of time, we had a bunch of certified people that didn't know anything, and they were convinced that going from CapEx to OpEx is good because they read it in the certification exam. They went to the cloud, organizations' budgets went sky high, farther than they ever worked. And now people are saying, no, we move that stuff back to the data center. Now, we're never going away from the cloud, Lady Godiva. But you're going to see a lot more multi-clouds and a lot more hybrid multi-clouds because the customers learn, hey, you can't put all your eggs in one basket. Look, Amazon doesn't even use CloudFront sometimes. Yesterday, we used Akamai. Today, I did an NS lookup on the Amazon webpage, and they're still using the Akamai website. So kind of keep that in the back of your mind. Michelle, yes, we're all still going to the cloud. Many things that were taken to the cloud are going to be pulled off the cloud and put back in the data center because the performance isn't as good. So I hope I answered your question that way, Lady Godiva, that some stuff is going to the cloud. Some stuff could be coming back off the cloud. All in all, we're going to be progressing most of our stuff to the cloud, but we may find it's cheaper to build our own clouds, like any Nutanix cloud on an OpenStack cloud, and then go back to the cloud for certain things the cloud does better. Website scalability, for example. Kind of keep this in the back of the room. I can probably do one more question. And
okay, I'll give you one more if you stop, because you could keep talking about that one forever. So
good point. Are all this Kinesis server serverless? Yes, they're serverless. Now that's the problem with serverless, Elvis, is you've got no control over it. But yes, they are serverless, which means you don't have to deal with a virtual machine or anything like that. And I have to answer Sumit Kumar's question. Does Google have its own servers? All clouds are a bit the same. They're data centers, which means they're buildings filled with routers and switches and servers and storage and firewalls. All the cloud is a data center. It's nothing more than a network and a data center that they sell you a percentage of it. So of course they have their own servers, hundreds and thousands, if not millions of their own servers. So as does every cloud provider, as does every business. Now let's go back to the AWS server. And actually but it's a good question, Summit. So before we go back to the content, if you guys can give me all a hashtag AWS Certified Solution Architect Associate. Alonzo's perfect. Consider the cloud a timeshare. I like to view it as a hotel room inside of a big hotel. Exactly best way to look at it. Again, I'm seeing this AWS Solutions Architect Associate, more AWS Solutions Architect Associate. Watching from Cambridge, I love that. I haven't been to Cambridge in a little while. Alonzo, AWS Certified Solution Architect Associate, and Shimeless. There you go. You're down there using an abbreviation. No abbreviations for architects. But we're thrilled to have you here, Timeless. And Timeless, I actually had some Injera yesterday. And some of my other favorite things. So let's talk about Elastic Beanstalk. Now, Elastic Beanstalk is one of those automagic things, and automagic makes people like me terrified. Basically speaking, Elastic Beanstalk provides the necessary tools for web deployment. What'll happen is it'll automatically deploy your tools. So what happens is you'll write some code in either Go or Java or .NET or Node.js or PHP or Python or Ruby. And what happens is Elastic Beanstalk is going to manage and provision the environment for you. Then it's going to monitor the health of your systems and scale or not scale for you. Now think about having something that's done for you. It's never going to be optimal. It's never going to be smooth. It's going to be whatever the computer is determined for you. So it's like going to McDonald's and saying, I'd like a Big Mac, fries, and a Coke. It's never going to have that degree of customization as if your grandmother made it for you, or you made it on your grill, or your wife made it for you, or you made it for your wife. So keep that in the back of your mind. All these automated systems are great because they save time, but you also lose something along the way. So let's look at the concept of Elastic Beanstalk. You basically put in your code, and poof, it automatically deploys a fully redundant, at least in a single cloud environment for you, for your web applications. Now let's talk about Amplify. Now Amplify is a service for the quick deployment of full stack web and mobile applications. And what happens is full stack applications are made in the front end, in which the user basically sets up their interface, and the back end refers to servers, code, and databases that make the app work. Now, a developer can create the application without needing to manage services, virtual machines, or storage. Yes, you don't have to do it, but what happens when you don't do it yourself? So let's talk about Amplify. It includes three main tools for development and testing. We've got the AWS Amplify Studio, which is a web browser-based visual deployment interface. It allows for simplified drag and drop configuration of the application's front end and back end. And then, of course, we've got the Amplify CLI, which allows command line development of the application's back end. And of course, the developer can choose from up to 175 of AWS services to build and support their application just by writing a few lines of code. Amplify hosting, it can update, push new updated applications to the internet. Code can be retrieved from a Git repository or Amplify Studio and for place, and then deployed in CloudFront's content delivery network. Now let's look at App Discovery. App Discovery is a service that helps enterprises migrate their on-premise applications to the cloud. This service reveals about the business case creation and application migration planning. Look, business case creation is going to need to be done by somebody that knows business. This can give the people that are going to do this some insight, but no application can build a business case for you. Some of the data will be, the cost of operating in cloud versus on-premise, but look where the data is coming from. The cost of migrating information to the cloud, the cost of leaving your current infrastructure, the benefits of being in the cloud, the cost of doing nothing. Now, when I learned how to practice medicine, they were very careful. Look at the source of the information. If you're dealing with a drug company funded study, chances are the study is going to be supporting things that's funded by the drug company. When a cloud provider is making something that's going to build a business case automatically for you, it's probably going to be biased towards them, meaning they may use overly high pieces of information for they think you'd have costed for run your own systems, which may be accurate or may be totally off. Now, App Discovery makes migration easier by allowing enterprises to make better decisions because it's a tool. From this data, companies can rapidly organize, track, and ship applications to the cloud in what it predicts is the most efficient way. Again, analysis by the human mixed with App Discovery magic. One application by itself, not so good. Not looking at data, not so good either. So it's a combination. It should never be gut. It should always be data plus human intervention. And when we deal with AWS Application Discovery Service, it collects information like CPU, disk space, and network usage performance. Now, captured data can be used for the analysis of network efficiencies and deficiencies in between your systems. A little more about application discovery. Basically speaking, it's used to collect detailed information about an enterprise's on-prem data center. It then uses this information to form the most efficient and cost-effective migration strategy to the cloud. Keep that in the back of your mind. It's from the cloud provider telling you how the cheapest way to do it. From this data, enterprises can determine total cost of ownership, benefits, etc. Let's talk about AppFlow. Now, AppFlow is a bidirectional service, meaning it goes in two directions, that moves and synchronizes data from third-party applications. Software as a service, for example, like Salesforce or Slack, to AWS services without having to write code. The synchronization service, we've had these for a long time. All that's needed to do is to configure your data transfer requirements, and AppFlow will take care of moving your data between SaaS applications. SaaS meaning software as a service. Think about Microsoft 365. Think about, for example, Salesforce.com, software as a service. Zoom, software as a service. By aggregating data from multiple sources, companies can make observations, create hypotheses, and draw conclusions based upon the information that's been consumed. AppFlow can help determine the total amount of money a customer is spending on a user's business as products during their lifetime. AppFlow can improve operational efficiencies by connecting application services and processes and devices to automate workflows. And anytime we can automate workflows, theoretically speaking, you can reduce real-world errors and reduce the overall cost of business. Now, AppFlow modernizes data governance and clarity of the movement of your data between these applications. Usage for AppFlow is to quickly integrate your applications, to transfer your data at a massive scale, and to automate your data security. Let's talk a little bit about AppSync now. AppSync is a simple solution that enables multiple applications to be connected and synchronized with data from multiple sources, including databases, Lambda functions, and OpenSearch. Now, AppSync automatically manages and updates the data in web and mobile applications in real time, and updates the data for offline users as soon as they connect. By doing this, it combines all the data from multiple applications and simplifies the processing of transforming data to the cloud. AppSync uses a publisher-subscribe model method to push or pull data from multiple sources. The template is used to define what data is going to be pulled and from what sources. A little more about AppSync. AppSync is a simple solution to really just move your information. It can synchronize your data from databases, Lambda functions, and open source. AppSync will automatically manage the updates from your web and mobile applications. Now let's get into Cloud9. Cloud9 is an integrated development environment, which is software that pulls together common tools that is used to build applications under a simple graphical user interface. Now, Cloud9 provides 40+ programming languages and provides developers within an environment with all the tools necessary to build, run, and test and debug applications and software releases. Cloud9 offers the ability to develop, deploy, and debug applications using a simple browser. You don't even have to deploy the application delivery environment. Now, this integrated delivery environment will help save time in developing new applications because there's not so many tools that need to be configured separately. They have automatic code generation and intelligent code completion features, which help cut down on the time. Just like when you send a text and there's a predictive text that finishes your word for you, this is what Cloud9 is doing, and it can really save you some time here. Now, Cloud9 will also identify bugs in real time. It'll highlight certain things in your syntax, and this way developers are not going to have to switch between tools because they're in a simple graphic user interface. This is kind of a very nice tool. These features enable developers to have an organized workflow and solve problems when they arise. Now we're going to talk about a service called CloudFormation, which has no place in today's modern world. Terraform has replaced it by using Terraform. You can deploy something in AWS, Azure, Google, OpenStack, and Nutanix all at the same time. By creating CloudFormation templates, which we're going to talk about next, you are locking yourself into only AWS and making it harder to create a high availability multi-cloud environment. But it's on your exam, so we're going to talk about it for the purposes of the exam. CloudFormation is an infrastructure as code service. It provides a means for you to template known good configurations of your systems, meaning you've got a web server with a certain level of patching and a certain amount of information in it, and you can use CloudFormation to basically provision that server exactly, or provision all your things. Now, CloudFormation would be great if it was worked on multiple clouds like Terraform, but it doesn't. But CloudFormation templates can be made via simple text files or via any of the supporting languages. Look, it's the Amazon proprietary version of Terraform. Here's what it's going to look like. You're going to code your information, infrastructure. You're going to store your template in S3. You're going to launch that template, and it's automatically going to deploy your information exactly where it's supposed to be. Exactly where it's supposed to be. CloudFormation templates are available for a multitude of options. You can write them from scratch in either JSON or YAML format. YAML format, you'll recall, is typically used in Kubernetes deployments. The code is either stored locally or on S3. The code is either used by the CloudFormation. You can use it in the console, CLI, or of course the API or programming interface. CloudFormation will provision your systems based upon the template. CloudFormation can deploy your templates across your infrastructure. And CloudFormation also has a couple of stacks. All resources managed by the template, the CloudFormation template, are called stacks. Briefly, we'll talk about a new service called CodeArtifacts. AWS CodeArtifacts enables users to store software packages used during application development. The software packages are stored in a repository like GitHub, so they can be accessed for future reuse. The packages can then be simple files, reports, or logs. Why your company needs AWS CodeArtifact: it reduces delivery time by encouraging code reuse, just like Git would do. It's a fully managed service by AWS, so it takes the stress off the management. And there's no limit to the number of packages you would like to store. CodeStar is a service that assists in the creating, managing, and deploying software applications. This service facilitates using a central console that can be used to assign project team members to specific roles needed to access certain tools and resources by a centralized console. CodeStar offers a single dashboard that integrates software development tools, thereby making it easier for managers, developers, and team members to collaborate on projects so they can use the console to track software development. Data Exchange. AWS Data Exchange is a data subscription service that allows the exchange of data between organizations. Customers can subscribe to various published data through the console. Data can be used to make data-driven decisions by using analytics or machine learning. With AWS Data Exchange, data providers can host data such as payroll information, debit card transaction, healthcare, and demographic data for the use of AWS customers. Now, if it's going to be healthcare data, it's going to have to be de-identified data, because otherwise HIPAA rules will get in the way. You can't say Mike's medical record is this, but you could de-aggregate the data and find out that you had 600 people that had heart attacks, for example, and try and figure out what's going on. A little more about Data Exchange. The data is produced as a data product that customers can subscribe to in the Data Exchange or the marketplace. Data in the AWS Data Exchange can be organized in these three ways: assets, which is just a piece of data; revisions, which is a container of one or more assets; and data sets, which is a series of one or more revisions. Data Exchange allows customers to migrate to the cloud with existing subscriptions by approved third-party providers. Some more new services that are part of the new exams: Associate and Professional. Device Farm. AWS Device Farm allows developers to test their applications by using visual devices available on the service without the need to buy physical devices. So basically using virtual devices. These virtual devices can cut across platforms, including iOS, Android, and other web platforms. So instead of buying an iPad, you can use a virtual iPad to test your code. This is nothing new. We've been using things like this forever. AWS Device Farm allows testers and developers to test their applications in the following ways: automated app testing, remote access integration, for example. Automated app testing, users can upload and choose the application to test, select devices and operating system versions, and the number of devices that are going to be used for the test. Users can select as many virtual devices as possible, different operating systems, as well as to get to the desired outcome. Users can then, remote access integration, users can set up a virtual device, interact with it while remotely achieving real-time outcomes. So if any of you have ever seen what some QA testers do in real life, you deploy something and then they create a fake 10,000 users and use Ixias to generate traffic and use other scripts to generate users. That's what this is doing. It's a nice way to simplify the testing across a wide variety of platforms. Let's talk about Forecast. Forecast is a machine learning tool to assist with business forecasts. It works on a time-based environment by analyzing data, oldest data first to the newest data, to help businesses make predictions. That's the whole point of machine learning in the first place. Amazon Forecast works by using machine learning algorithms to combine historical time series data with other variables to build accurate forecasts with the aim of predicting business outcomes accurately. To create a forecast project in Amazon, users work with the following resources: imported data sets, training predictors, and generating forecasts. Amazon Forecast is used when you want to predict business outcomes accurately, useful in fields like healthcare, retail, finance, hospitality. These things are useful anywhere when you're going to take information, aggregate it, and monitor it. So let's talk about where we would use it. With regards to operational planning, it can support business applications to predict amounts of web traffic, AWS usage, IoT sensor usage. We can use it for supply chain planning, for example, to allow business to predict how much goods and services they need to purchase when they need it. We can use it for retail demand planning. It'll give business the opportunity to predict demand based on historical data and associated data. So businesses can adjust inventory and pricing, for example. And it allows businesses to predict requirements for staffing, energy utilization, and marketing. Now we'll briefly talk about Global Accelerator. Global Accelerator is the way to get your stuff and data quicker. And what happens, Global Accelerator will use a built-in health check to make sure your endpoints are healthy. And what happens, it's a means to connect to the system. So let me whiteboard this out, how these things work. Typically speaking, these are done with like an Anycast environment. So let's share this. So I want you to think of this in the concepts of routing. Let's say you're here, the user. Let's say this is the user. And you want to connect to an endpoint with AWS. Now let's normally say this is your closest endpoint. And this endpoint is going to have an IP address of 3.3.3.3. That's where you're going to connect. And then let's say this is going to bring you all on to the AWS Cloud. Now what's going to happen is we're going to create an IP address that's 3.3.3.3. We're also going to use something called Anycast. Typically speaking, when we do something like this, and when you do something like this, let's say you have another 3.3.3 over here. And the other 3.3.3 is also going to be connected to the cloud. So the way this works is if your user's over here, what's going to happen is your user is going to connect to this 3.3 because it's closer to them. Let me move the user up so you can see the user. So if the user's over here, they're going to use this 3.3.3. But what happens if this 3.3 goes away? Delete. Now this user is going to connect to the cloud over here, which is going to get them to the cloud. So what these endpoints are doing is they're using a single IP address, and this is called Anycast. You'll see it widely used in IP multicast routing. You'll see it used in DNS. And it's creating multiple devices with the same IP address. Now, because we're using the same IP address for each one of these devices, which is really cool, we'll only be able to reach the closest one. And what's going to determine the closest 3.3.3 for us? Let's move this stuff up. Let me move some of this stuff over a little more to try and make it a little more clear to you. Because let's say there's a couple of 3.3s. Sorry, I'm on the wrong screen when I'm trying to do this. I want to make this picture clear for you guys. And we're typically going to have multiple endpoints when we deal with the global accelerator. And the goal is to get us to the closest one. Now, if we happen to be over here, this 3. Then in this particular use case, this 3.3 is here. But what happens when this 3.3 dies? Trust me, all technology dies. Then we want to go to this 3. Then we're going to be taking this to, this 3.3 will go here. And if this was dead, we'd hit the other 3.3. So that's really what we're talking about global accelerator. We're finding an entry point to get you onto the AWS network. And we want to find the closest entry point. But we also want to do it in a high availability manner. And that's why we're using EKS. Because if any one of these goes, that's going to be there. Now, how are you going to determine what's the closest 3.3.3? Well, if you're on your computer, you're going to have a default route. Your default route's going to take you to your internet router. And either that router is going to have a default route and use our ISP's information, or you're going to have two internet service providers, which you should be, have BGP, and BGP will determine what's the closest 3.3.3 for you on your routers. So that's kind of be the way this kind of works. Chris, how many minutes has it been since the last time I answered questions?
It's been about 20 minutes.
Okay, let's answer 10 minutes of questions if they exist. Do we have any questions in the last 10, 20 minutes or so? EC2 scripts are used per hour. Actually, they're used by, I think they're billed by the second, same as Fargate. But Fargate is serverless, which means you have no control over it, which means it could be cheaper. You don't have to manage anything, but you also lose control. Fargate is just a serverless environment in order to hold your platforms, your containers. You can put your containers on a physical server. You can put your containers on a virtual server. Or if you chose to go serverless, you could use the serverless environment, and the AWS branded them serverless as Fargate. And we'll talk about that later today. It's part of what's coming up. There was somebody saying that we explain real world problems. Yeah, that's the whole point. The whole point of us training you is to make sure you know something so you're potentially hireable in the future, as opposed to what's in certification where you pass a piece of paper and then you'll never be hired because the companies want to know that you know more than what's in that certification. So we intentionally provide context outside of just plain certification things. Any more questions before I move on? Because I'm happy to move on. Keep the flow up. I just want to make sure that everybody's doing good and learning. Meantime, I'm going to drink my ginger and turmeric tea that I made today, which is doing wonders for my laryngitis.
All right, I think we've given them long enough.
I think 3 just popped in.
Okay.
Any security, Dream Plan Act, that's the kind of thing we do in our Cloud Architecture Career Development Program. You know, this is a certification course, real training in terms of how do you design an architecture to get hired. That's exactly what we do in our Cloud Architect Career Development Program. Kwani, it seems when we want to be an AWS solution architect, we need to be less tech savvy and more of a business relationship. Well, not exactly. No, the difference between someone that's going to build it and an architect is twofold. When you take a certification course, it teaches you how to configure stuff. Now, as an architect, you need to know how to design stuff. And that's where everybody goes wrong. So imagine, Kwani, you wanted to design a hotel like an architect. And your training involved me giving you a hammer and a screwdriver. And you learned how to use a hammer and a screwdriver. Would you know how to design a hotel? Of course not. So for the architect, it's about knowing how the stuff works. What is the underlying technology? How do these things actually work? So for us, we have to design it. We need to know how the stuff works as opposed to how to configure it. Now, Kwame, as the architect, we don't touch the technology. We are 50 to 80% business executive. So we need to know all about how the tech works, not how to configure the tech, but how the tech works. But what we need to have is extreme business acumen. And we need to understand when customer says, I want to increase revenue, our options tech-wise to do it. To decrease manufacturing defects, our options to do it. We need to understand that we're going to be negotiating a deal, which is going to be $1 billion deal. We need to understand that we're going to be presenting at industry conferences. We need to understand that we're going to sell. We're never going to touch the tech. We're going to build it. So we need to know all the elements of the tech. And what are those elements? Networking and data center technologies. What is the cloud? It's a network and data center. So that's what we need to know. All the stuff we're going to use. Now, Kwame, let's say 50% of what's on this certification training is usable, and the other 50% is not. You need to know when not to use AWS WAF and when to swap it out with the Palo Alto firewall. When not to use a system like Macy, and when to use next generation intrusion detection and intrusion prevention systems. We need to know as architects why we would not use Kinesis, even though it's on a certification, and why we would use Kafka. We would need to know why we can't just use CloudFront, which is taught in the certification, why we need to use at least 2 content delivery networks. We need to know why we would use 2 clouds. We need to be able to build a business case to show a customer, look, this doesn't make sense moving this to cloud. This is bad for the cloud. Oh, wait, Mr. Customer, Mrs. Customer, move this to the cloud. Then we need to present it and sell it. So realistically speaking, 50 to 80% business as an architect and 20 to 50% tech. Now, we still need to have a lot of knowledge in tech. It's not how to configure the tech. It's how to design the tech. So think, the reason people get it wrong, Kwame, is they train to be a mechanic, like an airplane mechanic, and they expect why nobody hires them to be the pilot of the airplane. Doctors don't go to school to be nurses to learn how to be doctors. Pilots don't learn how to be airplane pilots. And lawyers don't go to school to get AWS certified to be a lawyer. It's just a different job. Great question, Kwame. Of course, I can probably do 1 or 2 more. So Global Accelerator, yes, is reason, well, the Anycast address is a point on the AWS backbone. It's using these Anycast addresses to get you to the backbone faster. Good question there, Ryan. Okay, so let's get back to the content. We've got an ambitious agenda for another hour and a half today. If you can give me a hashtag AWS Certified Solution Architect Associate, and for Brent, who just got a new keyboard, maybe you can give it to us twice because you weren't able to type for the rest of the week, and so happy you have a new keyboard. So let's get into Managed Grafana. Grafana is a service that's used to enhance productivity while making use of Grafana applications by taking away a burden of self-management, because it's a managed service. Grafana is an open source analytical platform that's used to visualize, query, and understand metrics stored anywhere in your production data center environment. It's going to be serverless, which means you don't have anything to manage. And so they say it's serverless and secure. Users can instantly query, correlate, and visualize operational metrics and traces from multiple sources. Now we're dealing with managed Grafana. It's going to be highly scalable. And because it's managed for you, you don't have the burden of upgrading your platform. Now, Managed Grafana provides a single dashboard containing all of your resources and tools. It's a highly interactive data visualization service for monitoring of real-time data. It allows for the easy integration with open source tools like AWS tools, third-party tools, and common data cloud sources. Now, Managed Grafana supports SAML, security assertion markup language, which is widely used everywhere, like Active Directory. It's highly secure, assuring data privacy and protection. It eases the stress of licensing and removing periodic licensing with Grafana because they manage it for you. Now, remember, they manage it for you. OpenSearch serverless. OpenSearch is an open source service that allows users to search, analyze, and monitor large volumes of data from multiple sources. It's going to incorporate visualization tools that provide information into unstructured and semi-structured data. In addition, open source integrates well with analytics, machine learning, and other mining tools. When data is captured and fully loaded into OpenSearch, it's going to use built-in services such as Grafana, full-text querying, autocomplete, or scroll search to search, visualize, and analog DOMs and get real-time insights into your data. And it can reduce operational overheads because it's open source, it's somewhat managed for you, and it's easy to use. Let's talk about another AWS service, a new one called Proton, which is an automated application delivery service that focuses primarily on containers and serverless workloads. Proton enables platform teams to enforce and control best practices in your underlying infrastructure. Proton is a service that separates the infrastructure and its code to promote effective collaboration between infrastructure teams and development teams. Proton provides the offerings of infrastructure as code, CI/CD monitoring in an efficient way for dealing with containerized and serverless applications. These templates can be used to replicate across various development, staging, and production environments, and users will have full capacity to manage, update, and troubleshoot as appropriate. This deployment is really a workflow tool for modern applications to help DevOps engineers achieve more organizational agility. Now we're going to get into something that's really cool. VMware on AWS. Now there's VMware on all the cloud providers. And this is really an infrastructure of a service platform that it basically offers a complete software-defined data center on AWS, on Amazon bare metal servers. So realistically speaking, you got two options when you go to these clouds. You can use their management console and all their stuff, which for many people is new to them. Now, most data centers for the last 20 years have been using VMware. They're fully virtualized, fully hyper-converged, just like a cloud. And everybody knows how to use them. And we're all comfortable with using them. And then when we go to the cloud, our cloud providers make up silly terms such as Elastic Compute Cloud, Compute Engine Instance, and all these things, which confuses customers. So now AWS and the main cloud providers say, hey, you could just use your same VMware stuff on our cloud. So basically what happens now is you can now use VMware on the cloud, use the same beautiful, elegant VMware interface that all your people have known for the last 20 years, not have to deal with any of those AWS management consoles or CLIs anyway. And while AWS can say, hey, we made a light mode, a dark mode, who cares? We're trying to do these things. This is basically letting your users use the stuff they've used with all the control they've been using forever. When they take their virtual machines from their data center to the cloud, they don't even need to convert them now because they're going to just move them directly and basically. So now it's the simple VMware user face, that same vSphere, all these kind of wonderful VMware tools that the people have used. And now they can easily push this on multiple clouds, all at the same time with an interface that's known. That means no real retraining of your users because they're going to do the same stuff they've ever done. And this means they're going to use the same VMware servers, the same vSphere, the same VMware virtual SAN, the same VMware NSX virtualization technologies, all in the data center, directly in the cloud. Nothing new to learn. So VMware on AWS, as well as VMware on the other clouds, will enable enterprise IT operations to continue to use their great services now on the cloud. So now they don't have to buy their hardware, but they can still use it the same way they always have. This is really great service. The offering enables customers to quickly and confidently scale up or down their capacity with minimal friction and simplicity of ease. The service is optimized to run on dedicated bare metal servers. So you'd be using the VMware hypervisor as opposed to the AWS hypervisor. Very simple migration, very fast disaster recovery, flexible in every way. And basically, hey, you get to use your same VMware now in the cloud. Nothing to learn whatsoever. Kind of makes learning all these services somewhat irrelevant because now you can do it all in VMware the way you always have, but without buying the servers. So that's what VMware is on all these clouds. Simple and elegant. Lots of customers are going to take advantage of this. Of course, if it's a new customer, they could go straight to the AWS EC2 versions. But if they've got this and it's deployed and their team knows about it, it makes it simple and elegant. They don't need to hire or cross-train new people to do the implementation. Let's talk about AWS Wavelength. And that typically exists outside of an AWS center. So with Wavelength, users can create their virtual machines, otherwise known as EC2 instances, block storage, otherwise known as Amazon Elastic Block Storage, and Amazon Virtual Private Cloud subnets in AWS Wavelength, and use services that orchestrate Elastic Kubernetes service, for example, and Amazon Cluster Services. What we're going to be dealing with is infrastructures are going to be deployed on 5G communication provider networks. And this is going to be useful when you've got a low latency environment, such as streaming applications and things that are going to be out there. Wavelength is really an infrastructure deployment embedded in a telecommunications facility like a 5G network. So this can be compared to a local zone that works with an availability zone, but with low latency. Part of AWS Wavelength, what you would have had it done is application traffic would have to travel from the device to a cell tower, and then a metro aggregation location, and then it could go to the internet before it could reach AWS. These network hops, anytime we're dealing with hops, could add milliseconds of latency. And by doing it this way, it's going to be closer. So think of an internet IoT devices that are going to go straight to this wavelength thing, pushed on the 5G network and back to the cloud. So there's lots of use cases for this. Amazon X-Ray. X-Ray is a tool used to troubleshoot and identify root causes of performance issues with AWS services. X-Ray looks at your application programming interface requests as they travel through your application and produces a map of your application. Developers can use AWS X-Ray to analyze and debug their applications. X-Ray will provide a full picture view of the request passing through user services, and it helps see who made the request to the service, when the request was made, and when the request came back. X-Ray was going to work by collecting data from the applications or services running in your system, and it will then aggregate or combine that data to form traces of each system. Next, what will happen is X-Ray will create a service map or visual representation that can be used to trace or debug or even troubleshoot each service. Users will be able to further drill down on each service to identify the root cause of any issue facing their application. Some benefits of using X-Ray are for auditing purposes, to trace requests made by your applications, to create a detailed service map of the applications running in your system, to help find bottlenecks in your architectures to improve performance, to help us identify the security posture by encrypting all traces, and to identify all traces. Okay, so now let's get into something funner. And yes, I know funner is not a perfectly good piece of grammar. So wake up, everybody. We're going to go talk about containers and container orchestration. So before I know that you're awake, I just want to know you're awake. Give me a hashtag solution architect or a hashtag cloud architect, and then we're going to talk about containers, which is one of my favorite things. Because virtual machines and containers are the basis of all computing in today's world. And while we're waiting for that to come in, Anakin, his question in there is quite real. All this machine learning, how fast does it become Skynet in the Terminator movies? Well, it depends how fast these things get used, whether they get used, whether they get checked, whether people get wild and crazy away with them. But automation can be great. Effie, to me, is cloud architect. Good to see you. Gavin, I'm loving this. I'm seeing solution architect, cloud architect. I know you guys are awake, alert, and oriented. And I do like containers. And actually, before we get to containers, I've got the perfect visual for a container that's going to explain the concept. And then after we deal with the visual for the container, we're going to start talking about containers. But let me get my container visual real first, because I had a really good container example before. So let's talk about containers before we get into containerization. I'm going to just share my perfect representation of a container. Okay, so here we go. So before we get into containers, here's what a container is. Normally speaking, with a virtual machine, what are we going to have? We're going to have a server. It's going to have its own operating system. It's going to have the application dependencies on the application. Here, before we get into containers, here do we have? We have an application. The application is represented by the beautiful Cindy the cat who's sitting inside. Now, if you notice, the cat put herself in a basket. The basket is the container. So basically, what container, and we'll talk more about it, is we're going to steal parts of the operating system or libraries from the operating system, and it's a fully contained application sitting inside of a container. Now I can take that container, from one Linux system and pop it on another Linux system by using the same Linux libraries. This is how I view a container. My cat Cindy demonstrates containers everywhere. And let's talk about containers. And everybody give me a hashtag Cindy while I start talking about containers, because Cindy is the best container teacher I've ever met in my entire life. So while we talk about containers, there's going to be 2 or 3 ways we can orchestrate our containers. Now, the first one I'm going to give you is AWS proprietary, and you probably should never use it in reality, because if you do, you're going to be in trouble when you have to use Azure and Google and Nutanix and OpenStack. Now let's define a container. It's a newer, more modern, lightweight version of a virtual machine. So in a virtual machine, we have the entire operating system. Every time we've got a server, I showed you on the first day, we have our hypervisors, and then we have a virtual machine. Each virtual machine has its operating system, application dependencies. Now a container is just like Cindy, beautiful little Cindy there sitting in the container. It's just the application, so that's all we're doing it. So by using containers, they're faster, they're lightweight, and we can use much less computing power. Now when we deal with containers, something needs to orchestrate these containers. And we need to separate them. So we'll talk about container orchestration in a minute, but what are we really talking about? In this particular environment, we've got our physical server, we've got our operating system, and then we've got a container on the operating system, a container on the operating system, a container on the operating system, another container on the operating system, and they're all isolated on the same operating system. So let's talk about the strengths and weaknesses of this approach. If container 1 crashes, it's completely isolated from container 2. So if container 1 crashes, guess what? We've got no problem with containers 2, 3, and 4. Now, everybody in the chat box, I want you to tell me this, because I want you to understand this. What do you think happens if the host operating system crashes to the 1,000 containers that are sitting inside of the system? Everybody tells me in the chat box, what's going to happen if the operating system crashes and I've got all these containers in this system? I want to make sure you understand this very critical concept. Good job, Alex. Boom, all containers are gone. Lady Godiva, you're gone. Abigail, bye. Yes, all data will be lost. Everything is dead. That's the whole point. So, containers, every technology we use has its strengths and weakness. Containers are beautiful because they're lightweight. But if that host crashes, everything else is dead. So kind of keep that in the back of your mind. It's good. We love them. There's a strength and weakness to every approach. If a virtual machine's operating system crashes, guess what? We only lose that virtual machine and its application. If we have 1,000 containers on a big giant server, they're all gone. But containers still make sense in most cases. Well, I'm going to tell you right now, when they do certification, they'll tell you can just migrate a container everywhere. Well, if you develop a container on a Macintosh, you can't put that container on a Linux machine. And you also can't put it on a Windows machine. If you have a Windows container, you can't put it on a Linux machine. If you've got a Linux machine, you can put it on any Linux server, or you can actually put it on a Windows system that's running the Windows subsystem for Linux, because the Windows subsystem for Linux is an Ubuntu kernel that's added to Windows. So keep that in the back of your mind. Containers are portable, but containers borrow things from the operating system. And therefore, a Windows container must be deployed on a Windows system. A Mac container, a Mac OS container must be deployed on a Mac. And somewhere along the line, we've got to orchestrate these containers. So if we're going to have containers, something needs to determine whether the containers need to grow, size, or control them. So let's talk about this, where you're at. One way that you can manage them, which I strongly don't recommend you ever use, is the AWS Elastic Container Service. And the Elastic Container Service is a 100% proprietary, AWS only, fully managed container service. Now they'll tell you it's high availability, which they call 99.99% available. That means that you'll have 1 hour during the year, expected 50 some minutes a year, where your systems won't work. That's best case scenario. Assuming the cloud provider doesn't crash. Now, Elastic Container Service is going to be deployed in your VPC, which usually means since it's in your VPC, you'll be able to use access control like NACLs and security groups to protect your systems. And Elastic Compute Cloud can work with Fargate or virtual machines, and I'll explain to you what they are. So here's the way you would typically build your containers. And this is the same with a Kubernetes environment or this proprietary AWS Elastic Container Service ECS, which locks you into AWS. If you use this Elastic Container Service, it's going to manage and orchestrate your containers, and you're going to have to build your containers. You're going to have to put your containers on a virtual machine. You'll manage your virtual machines, and then you'll manage your applications and then containers, and you're going to pay for your virtual machine. Now, if you wanted to run this in a serverless environment, which you could also do, you could run your Elastic Compute Cloud with Fargate. And what is Fargate? Fargate is an AWS-managed serverless environment that hosts your platforms. Because it's serverless, it means you don't need to manage your virtual machines. Now, potentially when you go serverless, it can often be cheaper because with a virtual machine, you may be buying more capacity than you need. Where when you go serverless, you're not. So, but also when you go serverless, you have much less control over your systems and your performance and your security. And you're now part of a shared service where if the shared service gets hacked, you get hacked. For example, Microsoft was just hacked. And what was it, 65,000 of their customers' information that was hacked? I mean, lots of information, because in one of these serverless cloud managed things, if the cloud gets hacked, you get hacked too, or at least it's a possibility. But with serverless, you don't have to manage it, which can make it simpler. So it's an architectural trade-off. Do I want more control? Don't go serverless. Do I want more performance? Don't go serverless. Do I want simplicity and elegance and lack of control? Less work to do? Go serverless. So Fargate is kind of that environment where it's serverless container orchestration or serverless container hosting. So instead, if we wanted to use Fargate versus a virtual machine, we've got the same Elastic Container Service, which is proprietary, which means you probably shouldn't use it, managing your virtual machines, and we'll build our containers, define the required compute capacity, and it'll be managed in this serverless platform. So potentially cheaper, much more agile. Now we can put our containers in a traditional virtual machine called an EC2 instance here. It could be the same thing if we were on Azure. We could put them on an Azure virtual machine. On Google, we can put them on a Google Compute Engine. It's the same concept. And if we need more control, obviously put it on a virtual machine. If you're looking for simplicity, stick it in a serverless environment. You and your business can determine exactly what's needed. Now, if Elastic Container Service is this proprietary service that I strongly don't recommend you ever use, what would I recommend you use? Kubernetes. Why? Kubernetes is an open standard. You can build your beautiful Kubernetes clusters with your own servers. Stick one server in your data center, one server in Azure, one server in AWS, one server in Google. You can have your multi-cloud container orchestration. Single cloud goes down. Who cares? You're still up and running in your 3 other clouds. Multiple control. Your cloud provider raises your rates. Guess what? You can leave and go to another cloud. Your cloud provider kicks you out. And we've seen cloud providers kick businesses out of their business, nearly bankrupting them overnight. If you're using Kubernetes, no big deal. You can pick up your containers and move it to any cloud at a moment's notice. Now, if you didn't want to build and manage your own standards-based Kubernetes cluster, but you still wanted to use a standards-based process, this is where the Elastic Kubernetes Service is. So it's a fully managed Kubernetes container management service, which means you don't have to build your own cluster. Now, Elastic Kubernetes Service is now in a single cloud. So if you use multi-cloud and the single cloud goes down, well, you got nothing. But if you're looking for simple and elegant in the AWS cloud, and you're looking for something that can work that's standards-based for your future, the Elastic Kubernetes Service is still a very, very good option. It's an open, Kubernetes, as you know, is an open source container management platform. It's the standard container orchestration platform in the entire world. And Elastic Kubernetes Service is similar to the Elastic Compute Service, which we just talked, container service, which we just talked about, but it's a standard, it's not proprietary. And whenever you want innovation, never use proprietary, because now you can migrate to different clouds should anything happen. Now with Elastic Kubernetes Service, we can host our containers in two places. We can post it on a beautiful virtual machine if we need extreme control, or we can post it on Fargate and there's nothing to worry about because it's giving us a pre-made platform. So let's look a little bit about the Elastic Kubernetes Service. We create an EKS cluster, Elastic Kubernetes Service cluster. This cluster is our orchestration platform. And from there, we can stick it serverless, which is Fargate, or Amazon EC2, which means virtual machines. And all cloud providers have the same service. Of course, you could build your own Kubernetes thing. Now, if you build your own Kubernetes thing, what's the weakness? Well, the weakness is this. You got to manage the Kubernetes cluster, which means you need to have someone smart enough to know what Kubernetes is and how to manage it. But when you do that, you get much, much, much more control over your environment. And you can create a higher availability system by using an unmanaged Kubernetes cluster where you've got your own servers and multiple clouds all at the same time. Now let's talk about another cool Kubernetes thing, Elastic Kubernetes Service Distro. And this is a service that's going to enable users to run containerized applications in their data centers. What is it? It's Kubernetes. Now this enables users to create a Kubernetes cluster with the exact version of Kubernetes used in AWS, EKS. The main difference between EKS and EKS Distro is that EKS is fully managed on AWS, where EKS Distro is basically a download of the AWS version of it. By using EKS Distro, users can deploy clusters in their data centers that exactly match AWS. EKS Distro can be used for hybrid clusters. If users want Kubernetes clusters that span their data center in the cloud, for example, when you need to use the cloud for extra capacity, you can use EKS Distro. EKS Distro could also be used for disaster recovery. You could set up AWS EKS to be the backup data center if your own data center goes down. Of course, you don't have to use anything proprietary like this. You could create your own EKS or your own Kubernetes environment with your own servers and not get locked into anything. You just have to know how to install Kubernetes and set it up, where EKS Distro gives you a very beautiful, simple, like click, click, button, install. So it's removing the need to actually understand what you're dealing with. Now let's talk about Elastic Containers Registry. You may have been familiar with the interface of, say, Docker and Kubernetes, where basically speaking, we had Kubernetes managing the container and Docker as a host, as basically a container runtime module. Docker to some degree is being phased out by Kubernetes, but let's talk about what this is. The Elastic Kubernetes Registry is a product that stores, manages, and deploys Docker images that are managed clusters of EC2 instances. The Elastic Container Registry allows developers to save configurations quickly and migrate them to a production environment, which is going to reduce overall workload and time. The Elastic Container Registry provides a command line interface and APIs to manage repositories and integrated services, such as the Elastic Container Service that manages the infrastructure for its containers. The Elastic Container Registry is a secure, scalable, and reliable service that accesses and distributes your application images faster, reduces downtime, and improves the availability of your containers. When to use EKS Anywhere. Basically, you're using EKS Anywhere, Elastic Kubernetes Service Anywhere, because it's going to simplify customers' on-premise Kubernetes deployment via management configuration to provide auto-scaling. It offers a consistent, reliable Kubernetes cluster environment with your on-premise, better than self-managed. I don't know that it's better than self-managed. They will tell you that it's better than self-managed because they manage it for you. Personally, when you self-manage things, you can always do better. Again, it goes back to, can you cook a better steak than you can get at McDonald's? You know, mass volume can never be done as nice as precision one-on-one things. But precision one-on-one things take a lot of time, effort, and money. And when you use EKS Anywhere, it's going to reduce your support cost because it's going to help you reduce third-party application tools. It's open source, and It's going to make it a lot easier when somebody else has done the hard work for you. A little more about EKS Anywhere. It's a customer managed service that's going to allow customers to create and manage Kubernetes clusters with optional support. It's deployed as an installable package that simplifies the creation. It then automates the management of these clusters. Okay, we're going to get next into IoT services. I think I talked about some AWS services, and I think I talked about some Kubernetes things and container things. So might be wise to take about 5 to 10 minutes and ask your questions. Pradeep had asked a couple. There may be others that I don't know about. Do Windows containers exist in the real world? They sure do. There's certain base Windows workloads and containers that people use. As a rule, Pradeep, most real computing in today's world is actually done on Linux, but there are still some Windows-based applications that are very commonly deployed in the enterprise environment. But much less of them. Good question, Pradeep. What's the difference between ECS and EKS? ECS is a completely proprietary container management system, and because it's completely proprietary, you should avoid it at all costs. The Elastic Kubernetes service is, again, an Amazon-managed version of the open standards-based Kubernetes protocol. They're completely not the same. One is 100% proprietary, and one is a managed for you open standard thing. Good question, Pradeep. Is Fargate software as a service? No. Fargate is container management, a container hosting platform. Software as a service would be like Microsoft Office 365 or Zoom. There's an OpenShift. How is it different than K8? Okay, love the song. Meet the new boss, same as the old boss. So, you could buy, let's say you're in the US, Pradeep, you've got a runny nose. You can buy a Kleenex, you can buy a Puffs, you can buy a Scott tissue, and it's all the same thing that you would use for your nose. It's a facial Kleenex. You can have a virtual machine. You can call the virtual machine a virtual machine. You could call it Elastic Compute Cloud. You could call it a compute engine instance. You could call it anything you wanted. So OpenShift is the Red Hat managed Kubernetes environment. Same thing, with excellent support. Instead of being freeware, you get really good support from Red Hat with OpenShift. It's Kubernetes. Is Kubernetes the best container to use? Well, Kubernetes is container orchestration. If I was going to be using containers, it wouldn't be anything other than Kubernetes, and here's the reason why. There's lots of cool stuff about Kubernetes with regards to self-healing and auto-scaling, but it's standards-based, which means deploy it in your cloud. You don't like your cloud, take it to another cloud. Don't like that cloud, take it to another cloud. Cloud provider raises your rates. Buy a cloud provider. I'm going to this cloud provider. They're cheaper. Multi-cloud environments enable much better negotiation of pricing. Multi-cloud environments provide much better security. Multi-cloud environments promote much greater security. And innovation comes, Eric, when you've got the ability to change things fast. And when you're locked into proprietary things, it avoids things. So Kubernetes is probably the only container management platform you should ever use. Mauricio, can I explain the relationship between Kubernetes and Docker? Sure. Kubernetes is an orchestration platform. And Docker is a container runtime platform. So imagine you went to a symphony orchestra, Mauricio. You've got this guy that's making sure that people are going to the right pace. And then you got a drummer, and you've got a flutist, and you got a guitarist, and a harp player, and all these other things. Kubernetes is the orchestration that controls who does what. And Docker is a runtime module where you can basically run your systems. So think of it this way. if we go back to this, let me go back to it real quick. In this graphic that I showed you, typically what you'll see is you'll have a server, you'll have the host operating system, in which we intentionally didn't draw in this video because I didn't want to make it complicated, is you'll also see some kind of a container runtime module. This container runtime, and in many cases, this is Docker. But there's other platforms that could actually do that. Good question there. Really strong question. You were paying attention. When you create Linux machines, you wouldn't use a Windows VM, you would create a Linux machine. A virtual machine for Linux is using Linux. A virtual machine for Windows is using Windows. Can you just have Fargate? Of course not. You need something to control the things. So imagine you had a car, but you didn't have a driver. But would you have? Nothing. So the Kubernetes is kind of the orchestration that's driving the car. Otherwise, you just got something that's got an engine in it, which you can't use, tires, which you can't use, and oil and a whole bunch of other stuff. Would you say that we need to be more able to visualize between the relationships between technologies and conflicts and cost analysis? Kwan, you can't do this job if you can't understand the relationship between the technologies and how they can impact business performance and how one technology affects another technology. The same way a building architect couldn't design a building if they didn't know about the strength of steel and the strength of glass and the strength of cement. That's why certification teaches the name of a service and how to configure that service. But that's why we do very separate training for architects. Exactly well put. Well, there's a lot of things that go into a worker node in Kubernetes. So if you want more information about worker nodes and containers, we recently released a video on Kubernetes. Someone from my team can pop that in the chat, pop that in the link. What are some of the popular containers other than Docker? It's either done via Kubernetes is going to be having its own thing, or it's just Docker, and that's pretty much your only container runtime modules we possibly use. Leaving one provider for another provider due to cost could be a bad decision. Why would it be a bad decision? So let's say you need a brick, Kwame, and you go to one store to buy a brick, and then another store sells the bricks for 50% less. Why would it be cheaper, bad to go to another place that gives you the identical bricks for 50% less money? It's the right thing to do. So people went to the cloud. Sometimes they leave the cloud to cost, go back to a cloud to cost, go to a different cloud for cost. Kwame, this is what architects do. They help businesses be as operational, efficient, and smooth as possible. Business makes a bad decision, you got to correct that decision. So I guess what you're trying to say is, hey, wait, I bought a car that was too much money. Hey, wait, why shouldn't I buy a better car for less money? So no, it's not like one cloud provider is going to be cheaper because they're not as good. It's the same thing. Thanks for the wonderful training. Could I give an example of multi-cloud for a specific industry, maybe CRM? Yes, man, that's what we do in our Cloud Architect Career Development Program. We give as much free training as we can for free, but that's what we do is we create architects. We know that other people are charging a lot of money for certification, and we feel certification should be free. We train people to be architects, and that's what we do in our Cloud Architect Career Development Program.
All right, this is the last one, and then I got to make you go back to work.
For a multi-tenant app, I don't even know what you mean by that. Can you create a single Fargate cluster? Well, you're not creating any Fargate clusters. You'd be creating a Kubernetes cluster and using Fargate to host your applications. And create a second service because of a business need I cannot use it. So Luis, I don't actually understand your question at all. So we're going to move on. Perhaps if you write that a little differently, potentially I can answer that for you at some point. Now let's get into IoT services. Well, I've been working with IoT stuff for 15, 20 years now. When I was at Cisco, we were starting to work with all these little IoT-enabled sensors that were going to be out there. There were going to be weather sensors, all kinds of plane sensors. Now IoT is everything from your refrigerator which is IP enabled, to your cable box, which is IP enabled, to little sensors where you can watch the beach and see what the beach things are for things like that. So AWS accordingly has a bunch of IoT services. So let's begin with AWS IoT Core, which is a cloud service that acts as a communication gateway, message broker, and device application interface for internet-connected IoT devices. It's the foundation for Amazon's solution offerings that come to deploying, managing, and analyzing and maintaining an Internet of Things infrastructure or architecture. As we discussed IoT Core, it's going to provide a scalable and fully managed solution that's going to supply and secure connectivity from devices, rule-based IoT, traffic manipulation, command control. Really what it's doing is it's going to enable your back-end fleet of cloud services. It can reduce the operational burden for your IoT devices by providing a platform that supports the communication and management. This service facilitates the communication from device to cloud services, applications, and other devices. What's going on is it has a built-in authentication and authorization RESTful API, which is basically a programming interface for command and control capability. Multiple IoT communications protocols are going to be supported because these things use lots of communication protocols. And you can create an access list to determine who or what can access the systems. And it's going to provide a registry to store the data. A little more on IoT Core. The service is going to be beneficial to a situation where there's a need to connect a fleet of IoT devices. Think weather sensors or airplanes that are constantly transmitting their information to back-end cloud services. This kind of access can give users the ability to process, analyze, and make actionable decisions from the IoT data quickly within a millisecond time frame. Now, this service can be handled by a device fleet ranging from a single device to billions or trillions of devices. When we're dealing with these kind of IoT devices, we're dealing with stuff coming from everywhere. Let's look graphically at what some of these pieces work like together. We've got an IoT device over here on the left. We've got some RESTful APIs that are sitting up top. We've got some internet-connected devices, and they're all going to be talking to each other through the IoT Core environment. Let's talk about device management. IoT device management is a device inventory and management service for Internet of Things connected devices. Organizations using the AWS Internet of Things device management service can easily register device information, configurations, and organize and inventory their devices, monitor them, and remotely update their software and firmware. IoT device management helps to track, monitor, and manage an entire connected fleet. And by doing so, it can ensure that all IoT devices work properly and securely after they've been deployed. The device manager provides the ability to access securely and get information about device health, defects. And by getting this, you can remotely troubleshoot problems while you're managing software updates. Talk about opportunities to use IoT device management. Remote fleet monitoring. Let's say you want to monitor your equipment's metadata and set a policy to change like a service alert so you can see what's going on. You want to perform bulk updates or control the deployment velocity, do some over-the-air updates like firmware and bug fixes. You want to define steady jobs for automatic updates. Let's say you want to create logical groupings of devices for, say, sensors in a specific area to organize and target a fleet of remote actions with a few clicks. Now let's talk about IoT events. Now this is going to be a cloud service that continually monitors data and applications and equipment for any changes in daily operations. If an event's going to occur, it's going to trigger a response. IoT events run in a serverless environment, so there's no host. IoT events monitor ongoing data from IoT device sensors and applications to integrate with other services like IoT Core and AWS IoT Analytics for early detection. This will help you gain insight and take action against your data. This service will help manage the state of your devices. A little more on IoT device. Events, it's going to monitor equipment for failures. and operations. And if you've got a device that fails, it can trigger an event. So you know what to do about it. Users will be able to take input from multiple sources, and will be able to move the device from using like IoT Core and collect analytics from IoT Analytics. So it gives you kind of things that are going on. Analytics can take the input and run that data on at the edge of your systems. Users can also route sensor data to IoT events. So realistically, IoT events are consistent with processing messages and are consistent with real-time reporting. Actions take place in real time, and IoT events simultaneously monitor multiple applications and sensors to detect critical events. IoT events also makes it easier to deploy, detect, and respond to events that happen across multiple devices, equipment systems, and applications. IoT events will assess the behavior and performance of the devices and identify issues based upon what industry it's being used in. IoT can help an enterprise, therefore, understand the conditions of their equipment. It takes more than a single sensor to get this kind of information, obviously. IoT events can learn new insights that will help you automate your operations faster. And by automating things, you can reduce costs. Potentially reducing costs and making better decisions faster can increase revenue and decrease expenses, which can enhance profitability. IoT events can help identify root cause analysis with device sensors and applications. And IoT events will enable organizations to really focus on their business operations and less about the IoT because it's a managed service. Let's talk about the IoT of Things graph. AWS IoT Things graph is a service that's to enable non-developers to visually create workflows between physical sensors, physical assets, and web services. By doing so, we can basically build a network across physical and virtual things. With IoT Things graph, we can quickly build IoT applications by connecting devices and web services from different vendors. And of course, when you're dealing with IoT devices from different vendors, they're going to speak different protocols, and the IoT Things graph can help do that. Basically, IoT Things graph gives you a visual editor that we can use to wire things together, such as web series and a workflow. Web series and web services in a step called the flow. I like to call things workflow. And because it's basically a hosted environment, you're going to pay for what you use, as opposed to just paying to have a system, like if you built it yourself. Now let's talk about AOT analytics. This is stored data. Why are we using it? We're using AOT analytics because it's a fully managed service that enables users to collect, manage, and ingest data from millions of sources. It's going to provide us a solution for collecting, processing, and analyzing data in real time. Anytime we can analyze data in real time, we can make better business decisions, which means potentially greater profitability. IoT analysis can help enterprises and device manufacturers quickly and easily gain insights into their data by collecting, filtering, and transforming things. So let's talk a little bit more about AWS IoT Analytics and the benefits of why we might use something like this. It's going to help by storing data in an optimized manner so we get faster response times. It can prepare data to be easily processed and analyzed. It can be managed as a pay-as-you-go service, which some people like, because that way they don't have to buy anything ahead of time. It's going to help the organization build applications that monitor in real time. It's going to be able to help monitor the efficiency of different processes for improvement. Okay, now we're going to get into cost management, at least as it's taught in the context of an AWS certification versus cost management in the context of reality. Because this is what you need to know for your exams in real life. We would obviously teach you how to do this in an architecture program, but this is a certification course, so we must do it the AWS way. When it comes to managing costs, we must understand that moving to the cloud can have a profound impact on a customer's costs. In many scenarios, going to the cloud will be cheaper. In some scenarios, going to the cloud can be far more expensive. So what's going to determine that? How the user, the systems they have, the capability of their systems, the performance of their system, the engineers they have, the architects they have, the technology people they have, and where those employees actually are. In most cases, moving to the cloud is generally cheaper, but not always. And that's where you're seeing a lot of organizations that first went all to the cloud, and now they're pulling half of that stuff on the cloud, putting it back in their data center, and they're still using the cloud, but they're building their own clouds and they're creating multi-cloud solutions. Now, I want you to understand the difference between the two. There is definitely a capital structure change. And here's the capital structure change. When you have a data center, you have predominantly CapEx. Capital expense is something I buy. A car is something I buy. I buy it once and I can keep it 4 years, 10 years, 20 years, depending upon how good the car is and how well it's maintained, right? That'll determine how long I can keep my car. Now, when you rent a car, if you were to go to the rental agency every day, it might be cheaper. It might be more expensive to rent the car because the cloud is just renting. Now, what'll determine if it's cheaper for you to buy the car and maintain it yourself or rent the car? How much do you drive the car, for example? What kind of car is it? What the rental agencies change versus what you cost to buy it, the kind of deal you get when you buy it. So these things are not simple. But you need to understand what we're talking about is a shift from a capital expense to an operational expense. And many people think this is a good thing. It could be a disaster. So for example, in our case, it was $10,000 to buy our stuff that the cloud providers were looking for around $11,000 pre-discount for us to do. Now, I just wrote a check and paid for the $10,000 of servers. It was no big deal. But businesses don't write checks. They finance things. So when you're building a business case as an architect, which is something I can't teach here, you have to teach it in our architect program, you're going to have to look at the organization's weighted average cost of capital and what it costs to finance it versus what it costs to use the cloud, which is effectively leasing. So this is going to be that lease versus buy decision. Now let's talk about why the data centers are so capital intensive. Well, there's a lot of stuff to buy, a lot of it. So first with a data center, you got to buy the real estate, right? So now you got to buy a big building. Now, the buildings aren't designed immediately to be data centers. You're going to have to buy your servers. You're going to have to buy your routers. You're going to buy your switches. You're going to buy your firewalls. You're going to buy your load balancers, your racks, your power environment. And look, data centers don't have power failures because you're going to be bringing in multiple power transformers, ideally 2 power companies. We're going to be having generators. We're going to be having backup generators, UPS systems and battery backup. We're going to be dealing with data center cooling equipment, and it's a lot of things. So when we go to the cloud, we don't have to buy any of that stuff. Of course, we pay far more for each service, but we don't have to buy it. Now in the data center, we have a big staff. You need a bunch of expensive Cisco certified internet experts like me to make sure the network actually works. You need a lot of people to manage the physical servers themselves. Lots of people to do parts replacements when something happens. You don't have to deal with that stuff in the cloud. There's no parts replacement in the cloud. Somebody does it for you. Now in your data center, trust me, these things generate some sky-high, scary electric bills, things that you can't even imagine. And then, of course, we've got to buy our wide area network connections. I've worked with customers that have spent hundreds of millions of dollars a year just for their network going from point to point. Now, in the data center, the majority of our costs are equipment. That's why the capital expense heavy. We still have operational expenses related to running the stuff and our people, but the primary cost for the data center is capital cost, purchases. And when we go to cloud, the cloud, there's nothing to purchase, but we pay far, far, far more for the use of everything we use. And on the cloud, we pay for everything. Like in the data center, you don't pay for data transfer charges on your wide area network in the US. You got a 10 gig link. You don't have to pay to use it. On the cloud, you get a 10 gig link. You have to pay for the link. You have to pay a daily fee for the link, and then they charge you to use the link that you just paid for. So, the costs are different. So it requires somebody with real business acumen to make a decision whether the cloud makes sense or not make sense, or whether part on the cloud, part in the data center. But for the purpose of your exam in the cloud, there's minimal equipment to purchase, which means there's low capital expenses because there's nothing to purchase, or almost nothing to purchase. But remember, the ongoing costs on the cloud are sky high. So for most organizations done properly and architected properly, which I'm going to tell you I'd say 2/3 get wrong, the cloud will have a lower total cost of ownership, because even if you're paying so much more for the tech, you're paying so much less to operate it, house it, maintain it. Now, when it comes to managing costs, here's the thing. Provision only what you need. See, here's where we can gain some benefits on some applications in the cloud. In the data center, we must provision for the worst case scenario. In the cloud, we can purchase on average use and use auto scaling. So that auto scaling thing and the agility of the cloud, being able to take a virtual machine and create it in 6 seconds, as opposed to calling Dell and ordering a new server, that agility is pure transformation for business. Step 2, properly size your resources. So use whatever the minimum amount that you need is, and then use auto scaling to scale out as needed. Don't over provision. Now, how else can you further reduce your costs? Decouple them whenever possible, decouple your systems. So we showed you how using an SQS queue or an Apache Kafka queue can reduce the need for bigger databases by smoothing out things that are going on. We showed you how using caching can reduce the load on your servers, so you need less of them. So by decoupling things in your architecture, you can put them together in an environment that can totally reduce your costs, many of the time. Now, step 3, use the right platform. What I mean by this is, when we looked at our 10 cloud server and we paid 10 grand for the servers versus 11 grand a month, that was on demand. Now, we could have reserved them and committed to buying them 3 years in advance, and instead of paying $360,000 or $380,000 for our systems, instead of the $10,000 that we paid to do it ourselves, potentially speaking, we could have got a 40% discount, knocking it down to say $200,000. Now, we have to understand that just because I built the cloud for 10 grand and it would have been several $100,000 on the cloud doesn't necessarily mean my 10 grand was cheaper. Because why was it cheaper? Because I have the firewalls here, I have the networking gear here, and I don't need to hire anybody to do it, because I did it in a couple of hours and I thought it was cool and fun. But if it was a production environment, we'd have to hire the people, and then it might be cheaper to the cloud. So these analyses are based upon the people you have, the technology you have, what you need, what you don't need, what's modern, what's not modern. So how do you structure your costs? Well, if you know your system use, reserve it and get a big discount. If you don't know your systems, use on-demand capacity. And as soon as you figure it out, go reserve it. Now, basically, you can reserve all your stuff based upon what your needs are. Use on-demand to scale as needed. Now, let's talk about the spot instances that we talked about the first day when we talked about computing. Spot instances are the kind of things that you use to bid on unused capacity. So let's think about bidding on unused capacity. You can get a very cheap rate for batch computing by using spot instances, but spot instances can get shut down. So the key is, when it really comes to cost optimization in your compute environment, it's going to be a combination of on-demand, reserved, and spot instances. How else can we manage costs? Well, it's often cheaper to use a managed service or serverless, because with the server, we probably have to over-provision. But once you go into managed service and serverless, guess what? You lose negotiation and bargaining power, and here's why. Your cloud provider knows it's going to be really hard for you to leave, and it may have costed you millions and millions and millions of dollars to restructure your applications to go serverless, and now you're trapped. You're locked in. So managed service and serverless can be good. It can be not good. It depends on how you use the managed servers and how you use the serverless, or using industry standards, which can get you to go to multiple places. Now, step 5 is, let's look at your data transfer costs. If you build your own wide area network, you basically buy for the links, but you don't pay to use them. Now we're on the cloud, they charge you to actually send data over your own links or over the cloud. So how do we minimize the amount of data we're sending off the cloud provider? Well, if we've got an S3 bucket or an object storage bucket in 2 regions, maybe we just replicate the data so we're not traversing the entire WAN. Maybe we use CloudFront so the web requests don't go across the cloud each time, or another content delivery network. like Akamai. And then maybe we look at what is our connection to the cloud. If we have limited data to send to the cloud, it's cheaper to use over a VPN. But if we've got a lot of data to send to the cloud, it might be cheaper to have a direct connection. Because remember, in a normal environment, you pay for the link and not to use the link. In the cloud environment, you pay for the link, a daily fee to have the link, and then you pay to use the link. And in many cases, it's more expensive to use a VPN than a direct connection. You've got a lot of data to send. The next thing you can do is you can set up a budget. And a budget can help by basically alerting you when you're spending too much money. So you can create a budget that says, hey, when I spend over $20 million, send me a message. And $20 million for an organization's cloud is going to be nothing. But I recommend you set up a budget when you're doing labs. Set the budget for $25. And when you hit $20, it's going to send you an alert. For $25, you hit this alert, or 50% along the way. And that way it's going to alert you if you've done a lab and forgot to shut off a virtual machine. So you don't get one of those multi-$1,000 bills at the end of the month that people do when they're training for certifications because they forgot to shut off a virtual machine. So create a budget and set an alert. Businesses can do this and they're going to find out, hey, wait, spending lots of money here, do something else. How does the budget work? Well, basically you create your budget, filter whatever you want, and get your notification. Now let's talk about Trusted Advisor. Trusted Advisor is a tool made by AWS to help you save money. It's a tool made by the cloud provider to help you save money, which means pay them less. Is it in anybody's interest to sell you less stuff? No. It's kind of like when a drug company sponsors a study. Again, it's not objective, but so Trusted Advisor is an AWS tool designed to help you make better business decisions on how you spend stuff in the cloud. So it's a service, and what's going to happen is the Trusted Advisor service is going to look at your infrastructure. It's going to then compare your infrastructure to what it thinks is right based upon AWS best practices, and then it'll give you advice. Now, the good news, it can give you advice that you did stuff wrong from a budget perspective. It could also maybe tell you that you made some risks, things that you should fix too. So it's good to use a tool. The tool provides information, but the point is the tool is not the be all or end all. When you're using the Trusted Advisor, there's basically two versions. There's the kind that comes with the basic and developer support plans, where customers are going to get access to 6 security checks and 50 service limit checks. Or customers that are on business support plans or AWS enterprise support plans are going to get 115 Trusted Advisor checks, of which 14 are related to cost optimization, 17 are related to security, 24 are related to fault tolerance, 10 are related to performance, and 50 are related to service limit. Here's another tool that the cloud provider is trying to use to help you spend money, which means spend less on them, which is damaging to their business. So take it for what it's worth. Compute Optimizer is a free management tool that recommends AWS resources to increase the efficiency and reduce your user costs. Compute Optimizer reviews previous resources activity to use to distinguish between your platforms, like where your data is stored, for example. Compute Optimizer will compare your user activities levels to similar users or similar activities and give some recommendations. And Compute Optimizer will take on comparison and prevent graphical data. And it's going to explain its recommendations, what it thinks you should do to optimize performance, reduce cost, and risk. But as a tech device, it's giving you information. Now, with Compute Optimizer, clients are given the opportunity to use the look-back option to review 3 months of long-term data history and make recommendations based on that. This service will enable users to utilize resources that theoretically reduce cost and improve performance. When users enable these suggestions, AWS will configure the resources to deliver optimal performance based upon business needs. Let's talk about service quotas. Service quotas are going to give the ability to view, log, and set limits on several services that integrate with the AWS dashboard. Service quotas will help users scale various workloads as workloads increase. Users can adjust service quotas or service quota values and monitor them by setting up alerts. And these alerts will inform users of pending limits. This will help keep users from having unintentional spending that's going to negatively impact the company's overhead. Service quotas is a good resource. It's going to look at your logs, and it's going to determine if there's a need or a place where you can save in a certain area. Theoretically, this can help control costs. Another tool, a well-architected tool, which is a free cloud service that's going to give you general guidelines and best practices. It's going to theoretically help plan to create better workloads. Here's the thing with a well-architected tool. It's going to recommend AWS services. And there may be many good reasons to not use them, such as you need good security way above what you can find, like next generation firewalls. You're going to need some more robust applications that are provided by AWS. You're going to need a more robust content delivery network. Look, right now, AWS isn't even using CloudFront. They're using Akamai right now. And that's part of what goes into a well-architected system, putting in the best tools from the best resources to deliver the best business outcomes. We have to be careful where we're getting this information. And a service like this is not necessarily going to give us exactly what we need to. Now here you can see now Amazon is using another content delivery network. Now they're using Fastly. And that's the point is, when it comes to high availability and when it comes to good architecture, everybody should ever use a single cloud. It's a single point of failure. Nobody should ever use a single content delivery network. It's a single point of failure. Amazon doesn't use a single content delivery network. We've gone through 2 content delivery networks in 2 days. So now we're going to get into building high availability architectures, at least what we're supposed to cover for the certification piece. Chris, how long have we been talking? Is it time for questions, or should I keep going?
We can see if there's some questions. The questions that have come in so far, I think they're more configuring, engineering. Okay. I'll let you, but I'm not 100% certain. I'm a business guy, but I'll put them up, and I don't know if we've got the time for them or the capability right now.
Yasmin, thanks for the one. Could we provide an example of multi-cloud for a specific industry or CRM? Well, Yasmin, it's not just going to be a specific industry.
We did that one earlier. Sorry, that's not the one I meant.
Okay.
Here we go.
Could you elaborate more on IoT from different cloud providers? Well, IoT isn't really a cloud provider thing, Yasmin. IoT are internet-enabled devices. So, I've been dealing with IoT in the data center for 15 to 20 years now. IoT devices are basically just internet devices. Now, Yasmin, this goes back to the whole architecture piece. How do you pick where it goes? What is the business case? What are you using the tools for? Now, when you know why you're using the IoT devices, and then you know exactly what you need to do, that's how you build the technologies. And that's, Yasmin, the main difference between engineering and architecture. This is a business discussion. You have to go to that executive at that company and say, what are you trying to achieve? And when you know what they're trying to achieve, what are they using the sensors for? Are they using the sensors for safety? Are they using the sensors to reduce cost, detect traffic patterns? Then you can figure out what technologies solve those problems. It's not like the tail wags the dog. The business will always guide these decisions. The tech is the last thing. So how do you innovate? First, you ask the executives, what do you need to do? Desire to do. Then you look at the balance sheets, the financial statements. Then you look at what industry analysts are saying about the business. Then you ask the managers in that business, the department heads in that business, the employees of that business. Then you determine what is the optimal end state. And then after you determine the optimal end state, that's when you go and you determine what technologies you need. And when you determine the technologies you need, then you can look at the available offerings from a cloud provider, as well as all the other partners that are going to be necessary to do it. And then as an architect, you need to coordinate, all the vendors. And it's going to be not just a cloud provider, it's going to be security providers, application providers, IoT providers. Put that information, document that information, draw a design, build the business case around that design, present that to design to the customer, and go sell that to the customer. That's what architects do. So you're asking a tech question without actually knowing what the business is. And that's why architects don't come out of certification courses. That's why we had to create a course like the Cloud Architect Career Development Program to teach these skills. I hope that makes sense. How do you configure AWS VPC security group subnets and other network resources when setting up an AWS cluster? You configure them Chimera the same way you configure every other thing, very simply, either with the Management Console, ALI, or CPI. Now, Chimera, if you want to know how to configure anything, you have two options. One is you can do our free AWS labs. I recommend you do them. And two, all you need to do is go to the AWS website, how to configure a network ACO. They will tell you step 1, step 2, step 3, step 4. Now, Kimia, I'm going to make this very clear to you. No engineer ever should configure anything from memory. Reading 5 minutes of documentation can save you 5 hours of troubleshooting. An employer will always prefer the person. How do you do this? Well, I'm going to check the documentation, and here's the reason why. Between operating system versions and management console versions, things are going to be changing just a little bit. Just a little bit. And those things will make the commands irrelevant. So every single time you should go to the AWS document and say, how do I do this? And they will give you step-by-step instructions. If you know what you need to do and you truly understand it, you can literally figure out the configurations in less than 15 seconds. But if you don't know what you need to do and you don't know what's going on under the hood, you're relegated to knowing how to configure stuff. And it may be the right stuff or the wrong stuff. Microsoft has just compromised at a massive compromise. Tens of thousands of customer information was taken and stolen. You know why? Somebody misconfigured their object storage. 16% of all hacking events occur on S3 because people don't know what they're supposed to configure and they misconfigure it. The configuration piece is easy. You can just read the AWS documentation. Knowing what to configure, that's the challenge. Hey, Mike. People who have an active Certified Solution Architect Associate certificate, should they take this exam right after training? If you already have the Certified Solution Architect Associate certificate, why would you take it again? I'm not sure what it takes to certify as an Architect Associate. Pretty much nothing. Follow this course, read the book, get a practice test, call AWS or register AWS, pay the fee, and go take the exam. It's pretty much nothing to pass the exam. And it looks like there's a question about our program, which I'm going to answer in about 15 minutes when we finish. That way I can spend the time to do it and not disrupt the actual class here. And I will answer a few minutes of career questions if you guys would like as well towards the end of this conversation. I don't have a lot that I can do, but I'll definitely answer my next questions. So before I come back, if you give me a hashtag AWS Certified Solution Architect Associate. So now we're getting into the part of this program which I hate teaching because it gives me cognitive dissonance. Because I'm going to tell you what you need to know to pass the exam, and it's completely inaccurate. So I'm going to tell you the accurate thing first. When it comes to building a high availability system, never use a single cloud. I'm going to say it again. If it comes to high availability, never use a single cloud. When it comes to high availability, never use a single cloud, because the single cloud is a single point of failure. If a cloud, no matter how many availability zones and region you use, gets hacked, you're down. If there's a major network misconfiguration, there's down. You're down. The whole cloud. If there's a network outage, they're down. If the control plane goes down or gets hacked, they are down. So single cloud is a single point of failure. Every cloud provider has had outages in the last few years. None of them have gotten to 4.9's availability. And I want you to think about this. If you, your mother, your sister, your brother was in a hospital on life support, and AWS or Azure or Google was the only cloud, and they had a cloud outage, and cloud outages happen all the time, and your systems that were keeping your parents alive went down, your parents would die. Would you ever want that? No. If you had a bank, by the way, where billions of dollars of trades were going on, and they were down, and the bank could literally go bankrupt with your money, would you want that? No. So a single cloud is a single point of failure. So when I go to talk about this, what I'm telling you is the stuff that the cloud providers are telling you as far as the exam. But likewise, Amazon right now has used 2 different content delivery networks in the last 2 days from the times we did an NS lookup on it. And I'm sure they use more than that. So keep that in the back of your mind. What I'm going to tell you now is passing the exam only. So when you're designing for availability, you understand that the higher availability systems you get, the more costly it's going to get. And we typically talk about availability in terms of nines. 99 is 2 nines available, 99.9 is 3 nines available, 99.99 is 4 nines availability. AWS calls that high availability. 99.999% availability is what I've worked on for the last 20 years. These are critical performance systems. Banks, hospitals, internet service providers, they all need to be at 99.999, as does any business. Imagine how much it would cost Amazon if you went to Amazon to go buy something and it was unavailable. That'd be a disaster, right? Now, if Netflix goes down for 30 minutes, who cares? But if you try to buy stuff on Amazon and they can't sell you for 2 hours, imagine what it would cost them. So most organizations would consider 99.99% available, high availability. Real critical availability systems like a bank, a service provider, healthcare would consider 99.999% available. Now, when you build a high availability system, you have to think about everything. The networking connections to the cloud provider, because if you can't reach the cloud, guess what? You've got nothing. Something my grandmother would call bupkis and my other grandmother would call dipota or dipota, which is nothing. So you means if you're going to have 2 direct connections to your cloud provider, your 2 direct connections should be on 2 different routers. And each router should have 2 different power supplies. Each power supply plugged into a different outlet. Why? Because if the power failures in the rack or the outlet, you don't want your LAN connections to go down. Now, the routers connecting to the cloud should have 2 brains in them and multiple cards where your wires are installed. And that way, you have no single point of failure. Now, when you build a high availability system, you could feel comfortable with the cloud because they maintain redundant power. Well, AWS has had 2 power outages, which took down half of their system in the last year. But the reality is data centers, and you assume a cloud provider has redundant power in their data center, so they won't come out with outages, which means they have redundant power. They have redundant generators coming in, redundant power companies coming in. So if they came down to a power outage, you can think about what that possibly could have been. Now, a good cloud provider like AWS is going to have redundant cooling. Why? If an air conditioner goes down or 2 air conditioners go down, their systems will cook and you'll have no cloud, so we have to assume they have redundant cooling. We know AWS has multiple redundant connections to the internet, and their backbone is highly redundant. Their routers and switches are highly redundant. And for people like me, building these environments is what I did in my sleep. I've been doing it for 25 years. But many organizations don't know how to do this. So for organizations without a bunch of network experts, it's often higher availability for them to go to the cloud provider than doing it themselves because they don't have the sophistication to do it. But for organizations that need it, they can hire people like me that have been network architects and high availability architects for decades. So when you build a high availability system, don't use a single cloud. But if you do, at least use 2 availability zones, which is 2 different data centers. Theoretically, according to that, the cloud providers can get you to 99.99%. I don't think any cloud providers delivered 99.99% in the last 2 years. But theoretically, they can do that. If you need better than that, use multiple availability zones, which is data centers in multiple regions. But if you're going to put your stuff in 2 different regions and 2 different data centers, just use 2 clouds. 2 data centers and 2 clouds is a much higher availability solution. So anything that needs high availability, like your server, should be put in multiple data centers. Your databases should be in data centers. Your load balancer should be in data centers. And of course, DNS or Route 53 is a single point of failure in a single cloud. Ideally, architect around it by using a real DNS service, the kind that you would get from F5 from the marketplace, and have your DNS servers in multiple places. Building a high availability network, make sure there's redundant connections, which means a direct connection, a backup direct connection, a VPN backup minimum, or a direct connection and a backup different connection. Now, if you're going to have 2 WAN connections, let me make this very clear. If you have two connections to AWS, this connection's from if this connection's on AT&T and this connection's on AT&T, you just architected a single point of failure. Because if you get a cable cut goes down on AT&T, you still got the other link. But if AT&T goes down, you got nothing. So for the last 20 some years, organizations building high availability systems always use two links from two providers, AT&T and Verizon and NTT. So when it comes to WAN building, you always use two connections. So each connection to the cloud should be through different people. So if you had an AT&T private line and an AT&T internet connection VPN, you just architected a single point of failure. Should AT&T have a global outage, guess what? You don't have any connectivity to the cloud and all your systems are down. So multiple connections. So if you're going to have direct connections, chances are you might want redundant ones. And that means you need to go to different direct connection location data centers. Because, for example, if you had your direct connection and it was going to a single direct connection data center, guess what? If that direct connection data center goes down, you lost your connection. So you always want to go to multiple connections, multiple places. Now let's talk about security. If your systems get hacked, they're not available. So use the principle of least privileges and IAM. Disable all unnecessary services in your systems. Regularly patch your systems. Micro-segment your system into multiple VPCs. Use things like organizations to reduce blast radius. Keep unwanted traffic out of your systems with access controls and security groups. Make sure you've got good security. So use a next generation firewall, for example, over WAF. Use some sort of a DDoS protection like Shield. Use strong physical security. If you've got a router over here and the router is connecting to the cloud and somebody can plug into the router, they can just plug an Ethernet cable into the router. Guess what? They got into the cloud like nothing. So make sure those systems are locked up. Make sure there's strong security around the wiring closet or data center. You need to use passwords. Use strong passwords. And template known good configurations for your team that are going to be deploying it in Terraform. So they can redeploy things that you know to be good fast. Make sure that your systems are backed up constantly. Backup should be stored in one location. If you're in AWS and you back up your data to AWS and AWS goes down, you're in trouble. Back up to another cloud, for example. Take your virtual machines or your service, create machine images of them so you can launch them somewhere else if you ever needed to. Now, how do you build some availability and performance? Well, use auto scaling. Why? You're under a DDoS attack and all of a sudden you get a multiple requests whether you can handle your systems with high capacity on demand. Decouple your application architecture components. If your database fails, but you've got a queue in front of the database, the queue can store your messages. Use caching. What happens if my website to www.gocloudcareers.com goes down? But I had everything cached on a content delivery network. You might be able to get to my website and see it while my web server is down because it's stored on the cache. Use DNS with health checks for load balancing. Use load balancers to increase performance and reduce single points of failure by sharing the load against 10 medium servers as opposed to one gigantic server. Constantly monitor your system so you can figure out what's going on. Look at the logs, look at the auditing events, monitor for security events, monitor your IDS, IPS system for security breaches, monitor the usage of your system, and monitor for performance. And lastly, change management. In a real high availability system, here's what it's like. Alonzo says, Mike, I want to change the configuration. And he sends a message to me. Who sends it to Chris? Who sends it to Leo? Who sends it to Chow? Who sends it to Manuela? Who sends it to Eddie? Who sends it to Anselm? And part of that change management request is, hey, if I change this thing at 3 o'clock in the morning, will this affect your system? And we can all analyze the change to see if it's going to cause a problem. And if we all say, go ahead and do it, then after Alonzo makes that change, he needs to check in with all of us and we need to retest our systems to make sure he didn't break anything. And if he did, we need to fix it. And that's why all these things are done, typically speaking, in the middle of the night. That's why I have lots of sympathy for engineers, because cloud engineers are doing work in the middle of the night. We architects are buying dinners and drinks. It's a little easier, but those cloud engineers, we got to have a lot of respect for them. 2 o'clock in the morning, they're doing work like this. Now let's briefly talk about passing the exam, and then I'll answer questions. The AWS exams are not difficult, but the way they ask questions can be brutal. They ask questions in a very wordy environment. There's typically not a winning answer, so it's select the best answer. The less you know about tech, the easier these exams are going to be, because if you know a lot about tech, these exams are going to be complicated because they're going to give you a question and there's going to be 4 answers. One might be the way Cisco would do it. One might be the way VMware would do it or Microsoft would do it. One would be the AWS way. So if you don't know a lot about tech, this is going to be a very simple exam. If you know a lot about tech, forget everything you know when you took this exam and just try to pretend that you just read this book and you just took this class and you don't know anything, and then it'll be very simple to get to the answers. But if you know a lot, it's going to work against you. So you almost want to shut your brain off and think exactly what is only on the AWS curriculum and take that exam and then be done with it. Now, I recommend that you look at this, watch this presentation again. You carefully look at all documents. You read the AWS white papers covering the services listed in this books. And here's the reason why. The AWS white papers are designed to convince you to go use and sell AWS stuff. What are these certifications? Certifications in today's world are designed to get you used to thinking about using the brand terms and helping to sell their stuff. So read those white papers. You're going to see a lot of questions from there. I strongly recommend you get a practice test. There's 2 companies that make practice tests that I like. Haman Sharma is the CEO of Review and Prep. He's a good friend and he's got excellent AWS practice exams. I also love Andrew Brown's content from ExamPro. He focuses on certification. I focus on getting people hired. Andrew and I are good friends and we recommend people back to each other. He sends me people for career stuff. I send him people for certification stuff. He also has some free AWS training. And I think for less than $20, guess what you get? You can get his practice exams, and they are really, really, really good. Now, I suggest you take a practice exam. And when you take a practice exam, you retake these exams until you can get a 95% or better on a practice test. Here's the reason why. It'll make sure that you are used to taking exams. And when you get used to taking exams, these exams will be silly easy. Trust me, they're nothing compared to some of the more complicated exams like a CCIE. But I will tell you one more thing. Because the way AWS writes these questions, they're ugly the way they're written. So the night before the exam, get a good night's sleep. Eat healthy. Don't go drink a bottle of Silver Oak with your buddies or have a bunch of scotches. Don't drink any alcohol. If you're in California, don't use any of the other substances that are illegal that can affect your thinking either, or Colorado or one of those other states. Keep your brain fresh and sharp the day before the exam. Arrive for the exam early, whether it's in person or not. I promise you, tech problems are going to occur. There's going to be some tech problem that occurs. Your system will freeze up by the security software they're putting in there. So be early. And if you drive there, be early. Don't try to be cheap on parking. When I had no money, I'd still pay the $20 for parking. Now it's probably more because I wanted to be there, relaxed, not worried to find a parking meter, worried about who was going to ticket me. And make sure you've got a valid photo ID for the exam. This way, you're out there, you're relaxed. And why am I so concerned with you being relaxed? I'll give you a little bit of the neurological reasons why. Right now, we're talking, we're having a good time. We're using the prefrontal cortex part of our brain. It's the thinking, the logical reasoning, the intelligent part of our bodies. Now, when we get nervous, what happens is the prefrontal cortex shuts down. This nasty thing called the amygdala kicks in. The amygdala is responsible for freeze, fight, or flight, and we get dumb. So be relaxed, be calm, be good to go. Regarding the amygdala, if you don't know what I'm talking about, let's say you're with your wife and she says something that would normally be no big deal, you deal with it. But if you're angry, you say something and you say something you regret, then you're in the doghouse for the next 3 years. Husbands can do it, wives can do it, best friends can do it. It doesn't matter. So kind of keep that in the back of your mind and you'll be good to go. Now at this point, I'm going to take questions. As for Brent stuff, I mentioned the 2 links. I get no financial benefit whatsoever I have nothing to do with certification as a rule. My world is getting people hired and teaching them how to be hired versus how to get certified. I just try to protect people from the really dangerous certification providers that are out there. And there are a few that I found to be pretty terrible. So I've recommended the two that I find that are the absolute best. Andrew Brown is a professional, and he has a big team that helps him produce quality content. And Haman Sharma from Review and Prep, he and I have spoken many times. He believes in quality. He's not someone that's going to take a bunch of certification exams and then teach stuff that he doesn't understand. He's going to have people that do it. So that's why I respect those two. Now let me take some questions. Let's say I can do questions for the next 20 to 30 minutes. Let me just drink some water for my laryngitis. Yes, I will happily answer any question now you have on the Career Development Plus live classes. What are the modules included in the courses? Well, I'm not going to get into detail of any of our modules because we do things a very specific way. If you ever saw the movie The Karate Kid and there was a wax on and a wax off, and then the kid said, "Why are you teaching me this?" And then the instructor, the sensei, started to show them how these things worked. We do our things that way for a very specific reason. There's a lot of things in our program that 99% of the people won't understand. But I will tell you our modules are based upon teaching you the following skills. As an architect, you must know these things. And if you don't know these things, you're not going to be able to work as a cloud architect. I'll cover the business and then the technical. Now, I'm going to tell you that the business components are far more important, or equally important than the technical. And let's go through the business performance. You must be able to have the business acumen to be able to understand a business's problems and be able to think about what that means and know the inputs and the outputs of a business. And by knowing that, you're going to be in a position to assist that business. And then next, you must have something called CXO relevancy, which means you must know how to speak to the CEO, the CFO, the CIO, the CTO. And we teach that, obviously. You must have executive presence, otherwise you won't be taken seriously or hired. So we teach executive presence. What is executive presence? Hi, my name is Mike Gibbs, and I'm a cloud architect. I'm here to help you. Now, do you think I can sell $1 billion architecture that way? No way. I'll be kicked out of the room. Now, if I said, hi, my name's Mike, and I'm a cloud architect, and I'm here to help you, people are going to take me seriously. So that's executive presence. Now, Manu, I'm going to have to build a business case as an architect, which means I'm going to have to show the customer that if they spend this $1 billion with me, they're going to get $2 to $3 billion of business value. So that means knowledge of how to create what's called a return on investment capital model. And we teach that, how to make those projections and how to deliver it so your customers will be willing to buy your stuff. Now, along with that, as an architect, your job is to design, present, and sell. So we're going to teach you how to sell the technology. It's just not like how you sell a car. It's partially on a business case. Now, Manu, when you're an architect, a lot of what we do is documenting. And you're going to have to be an expert in writing. And you're going to have to learn executive writing. You're going to have to learn how to write thought leadership and white paper writing, because that's a big part of your job. You're going to have to learn how to document your architectures, and we're going to teach you how to deal with that. Now, as an architect, you're going to respond to requests for information, requests for proposals, and requests for queries, because nobody buys something without these things. And we will teach you how to respond to an RFI, RFP, or RFQ, because that's part of the job. Now, next, we will teach you how to do those presentations, because you're going to be presenting at conferences. In fact, I'm going to tell you right now, part of getting hired involves delivering a presentation on architecture. Now, as an architect, nobody's going to ask you to touch the technology. In fact, recently, we even had Ivan Tambo on here, and I've been an architect for 25 years, and we never touched tech. But he told you that at AWS, as a solution architect, he's not even allowed to touch the technology. It's not part of his job. And because people don't believe me, so I brought in Ivan Tamba, someone we trained, had no experience, hired by AWS, just like many of our students that get hired by AWS with no experience. Now, we will also teach you as an architect, what's going to happen is you're going to have to lead a team of 30 to 50 people for every architecture. And we're going to teach you how to lead those teams. So those are the business skills we're going to teach you how to do. Now, when you have no experience, Minook, nobody's going to be willing to hire you unless you do some specialty things with your branding. And we know how to brand our students so that our students don't apply for jobs. Employers come to our employers like vultures and hire them without even applying. We will teach you how to do that. Now, next on the list, how do you design an architecture? Well, to design an architecture, you need to understand the technologies of the network and the data center and the cloud. Now, these technologies include BGP, which is the most common exterior gateway protocol in the world. And if you can't do this, you can't design an architecture. We will teach you interior gateway protocols such as OSPF, because that's going to be a big interplay with internal BGP and critical to the organization. We will teach you IP addressing design, subnetting, supernetting, route summarization, route aggregation, because if you do that wrong, your architecture collapses. We will teach you the critical switching technologies, which includes VLANs, VLAN tagging, VLAN trunking, spanning tree, rapid spanning tree, port channel, ether channel, link aggregation groups. We will teach you the proper use cases of NAT, one-to-one NAT, one-to-many NAT, static, dynamic NAT, and PAT. Now, when you're done that, we're going to make sure you know the data center technologies in depth, which is servers and server virtualization, containers and container orchestration, storage area networks like block storage, object storage, and file storage. And we only scratched the surface when we went through this, but we're going to give you the depth that you need to be able to design something. We will talk about the industry applications, ERP applications, CRM applications, unified communication applications, and many of the more things that you can use to optimize an organization's business. Now, we will get involved into database design, and then we will get involved in designing high availability, high security environments. We'll teach you how to work with next generation firewalls, IDS, IPS systems, VPN concentrators, and we'll teach you really about security so you can design a secure and highly available network. Then we will teach you how to translate all these things and migrate all that stuff to the cloud, in which case you can't migrate what you shouldn't understand, so that's why we're teaching you that. And then we'll teach you how to design a high availability system on one cloud. We'll teach you how to design hybrid clouds, multi-clouds. Now, the way we're going to do this is we're going to have 3 live classes per week. And in the 3 live classes, in 2 of them, you're going to design architectures with your peers. You're going to present these architectures back and sell them back to us. And in 1 of these classes per week, we're going to do leadership skills because they're so critical to getting hired. Now, in between live classes, we've got approximately 500 hours of training. You're going to watch a video, do a project, turn it in, and my team's going to give you feedback on it and make sure that you get better every day. We'll be giving you help on your interview training. We'll be teaching you how to negotiate a higher salary, how to negotiate a business deal. We'll be teaching you how to design things. You will have major architecture projects, the kind of things that would typically take 15 years of experience that are based upon my lifetime of experience in designing architectures for organizations. And then, of course, there's going to be labs. Now, as architects, we don't touch the technology, but we'll have you do some AWS labs so you can say you did it. We'll have you do some Azure labs so you can say you did it, but nobody's going to care. Then we're going to have you do real labs. So we're going to have you work with server virtualization the real way with our VMware service, so you know how to migrate the stuff to the cloud. You'll build containers in our program. You'll build firewalls and VPN concentrators so you're used to security. You'll build basic applications like Linux, Apache, MySQL stuff on the data center the hard way. And of course, if you're in our program, you're going to build an Active Directory server. And to make sure you're competent on the cloud, and to make sure you can show employers that you're the best, we will have you build an entire cloud from scratch. So while everybody else is worried about doing an S3 bucket, you're going to know how to build AWS as if they asked you to build the whole environment, the whole cloud from scratch, because every single one of my people builds a cloud from scratch. So Minix, I hope I answered your question on what we do in our Cloud Architect Career Development Program, which coincidentally is 30% off until tomorrow. So I hope to see you in class because I'd love to work with you and I'd love to see you get cloud hired. Is it necessary to learn K8s? Well, you need to understand Kubernetes and container orchestration. Not if you want to be an architect, we're not DevOps engineers. So we don't need to learn it like them where we're going to be hands-on. We don't need to learn, the kubectl commands and things like that. But we need to know how to architect it and how to design it, definitely. We teach that, obviously. Mauricio, in an AWS interview, should you mention multi-cloud approach? Well, I got to tell you, I've got about 6 or 7 people recently hired by AWS, and they were all talking about multi-cloud and high security. In fact, I will tell you that on average, once our students describe our security protocols on these interviews, a lot of times they get shut down. And they're like, okay, enough. You know security better than us. Let's go to something else. But when you interview, Mauricio, it's going to be dependent upon the case study they give you. And the case study they give you may need to be multi-cloud, may need to be hybrid cloud, or it may be a pure cloud. And you're not going to know that until you get the case study, because they don't just give everybody the same case study. Good question, though. You're already impressed and convinced with our reply, brief and awesome. Thanks so much. We'd love to help you. Is there anything in the labs that we should practice more than the other? Kwame, it depends on your job, what you're looking for. If your goal is to be an architect, it's not about hands-on labs. It's about knowledge of how to design the systems. If your goal is to be a configurer, then in practice everything. So I don't know what your goals are. But as an architect, we don't configure as part of our jobs, but that doesn't mean you still shouldn't know how to. But if you really know what you're doing, configuring is easy. Pirata 911, thank you for your hard work, Mike, and everything on the team. You guys are awesome. Thank you so much. We work very hard to make sure you guys are all successful, and I totally appreciate it. Sir, you're doing a great session. Thank you so much. Submit. Thank you so much for explaining so many complicated concepts. We are so thankful and honored to do it. I love sharing my knowledge. I've been in this field for 25 years. Now my goal is to get anybody that wants a cloud job, cloud hired, and to create the new generation of technology leaders. Jennifer, thank you. We're so happy to help. Kwame, single most important to be a great AWS solutions architect, communication skills. Because if you don't have good communication skills, you'll never be able to get the customer requirements, you'll never know what to design, and you'll never be able to convince them they need it, and it'll be stuck in PowerPoint. Chris, we already addressed that. Dan, thank you. We'll definitely join our class. Can't wait to meet you, Dan. Get to see you live on Zoom. Signless, you have a great team. Thank you so much, Signless. So nice to have you joining us. Kwame, what is the average graduate salary hired out? Are they all hired as AWS, or do some get hired with different job titles? We've got people getting hired as lots of things: cloud architects, solution architects, cloud consultants. Our average salary lies in the most frequent salaries were between 120 and 287 this year. I'd say the average salary for somebody that's never worked in tech before is about 150, 160 after graduating our program, which I think for a program that costs $700 on sale is pretty amazing. But we have people that work in tech that typically come in at 250 to 280, but they have tech background, and we just taught them how to go from tech, being an engineer, to being an architect, which is a big transition and lots of lessons learned. It's sometimes just as easy to go from engineer to architect as it is from like doctor to architect, because the jobs are so different. It doesn't matter the background, we know how to work with people. Chow says she might be a bit biased, but she totally agrees with you, Shameless. So that is the super amazing Chow. Chow came to us about a year ago. She's so incredible that she's been functioning as a teaching assistant with us. We love her in every way. We'll be losing her soon to a major cloud provider, but we still love her. Anakin, how do the type of questions in the solution architect compare to the ones for the professional? On the professional, they're really poorly written. And on the associate, they're easier to understand. That's the main difference. What we provide involves years of business school, years of Cisco, and something that goes way, way, way and beyond TOGAF. TOGAF's a theoretical framework. We get down and dirty. You're so welcome. We're so thrilled you were here. Is AWS still the leader in cloud? Well, all in all, AWS and Azure are the two market leaders. AWS is better than Azure in some ways. Azure's got more cloud revenue technically, but that also includes Office 365. AWS, Azure, Google. Here's the thing, it's all the same. It's kind of like if you, let's say you were in the US and you needed a brick, and you could go to Ace Hardware, the brick store, Azure, or Home Depot, Lowe's, and still buy a brick. It's all the same. Good dive. I'm always thrilled to see you. Peter, we do not code as architects, and you do not need code. We don't touch the technology. We design it, present it, and sell it. Collins, you're more than welcome. Prakash, it was so nice having you here. Next Zoom class will be awesome, and I'm looking forward to it on Tuesday. Louise, great band. I'm so thrilled you're here. Addie, how many programs or months will a program take? It's dependent upon you and how fast you get through it. In my experience, it takes about 8 months for someone to get through to get hired. But we like to stay in the program for a full year, just because I'm not obsessed with, kicking you out of the program. I'm obsessed with getting you guys hired. And you could get hired in 6 months, you can get hired in 4 months, you can get hired in a year. I just want to know we've created the best and supportive environment where you can continue to remain in classes for up to a year until you're hired. And that way we know that everybody's going to get hired that comes to our program as long as they do the work. Now that's the key, do the work. You want to think like a cloud architect. Can you use these bootcamp videos as a study guide to be competent while studying the book? Well, Leola, what we taught here is how to pass a certification exam. What we do as an architect is extremely different. And this kind of thinking, which is taught here, is certification thinking, which is not architect thinking. And that's what we have our training program. But this will help you get a certification. The certification will help you get an interview. And then all the studying and learning that you do on the back end is how you're going to get hired and learn to think like an architect. Thinking about joining the class, how long is the class? It can be up to a year. How many times a week is it? It is 3 2-hour live sessions per week. And you do the certification at your own convenience. There's no point in doing the certification first. The more you know about the cloud, you can do the certification with 1 or 2 days prep. I wanted to test my theory. The only cloud I never worked on was the Google Cloud. So I wanted to see how long it would take for me to pass the Google Professional Cloud Architect exam, which was the hardest one. I bought the book from Cybex, the official thing, kept my cloud knowledge that I had, passed the exam 2 days later in 45 minutes because the exam questions were so easy. There was nothing to them. I don't think I got any wrong even, and finished it in 45 minutes. So the point is, I'd rather take you now. I'd rather train you to be a great cloud architect and do the certifications at any one point. I want to make sure you're competent and capable. Zane, you enrolled a few days ago. We're thrilled to be working with you. Can't wait to see you. Thank you guys for the hard work. You highly appreciate it. A lot of people who showed me up this week. We're thrilled to have you here. You'll always come back for more. Jason Prompter. Do you need to know Python? No, cloud architects don't touch the technology. We design it, present it, and sell it. We're not software engineers. We're not cloud engineers, and we're not DevOps engineers. And I'll answer Manoj's last question, and we need to protect my voice. Our course covers everything you need to know to be a cloud architect. Everything, everything, everything. There's nothing that you need to do outside of our course other than read our required reading, which is, by the way, free. If you take a certification exam with a cloud provider, you pay them. I don't think Azure charges for their exams. I don't think Oracle charges for their exams. AWS charges for their exams, but we provide everything that you need to know. And the difference between a solution architect and a cloud architect is going to, because I'm sure that's going to come up, is as follows. A solution architect only knows one cloud. I work for AWS and I only sell AWS, so I'm a solution architect. I work for Accenture and I design a solution for my customer that involves 3 clouds. I'm a cloud engineer, of course. I'm a cloud architect. Times of the live classes are Tuesday at 10 a.m. Eastern, which is 7 p.m. Pacific time and 3 p.m. UK time. Thursday's class is at 4 p.m. US time, which makes it 1 p.m. Pacific time and 9 p.m. UK time, because I saw the class cop. And then Friday is at 1 p.m. Eastern, which is 6 p.m. UK time. And that's realistically speaking all the questions that I can answer with my voice. But I'll be back on Monday if any of you guys desire. But if you want to take advantage of the 30% off discount code, the coupon code is security and it expires on Sunday. So my team will provide a link to those courses no matter what. Whether you join us in our program or not, it's been such a privilege and an honor to be with you this week. I hope you guys all learned a lot. Make sure you download a copy of that free book. Make sure you learn the AWS labs and sign up for them. They're completely free. And join me on Thursday on the How to Get Your First Cloud Architect Job webinar. I look forward to seeing you there. Take care, everyone, and have a wonderful day.